Hey guys, I hope you guys are doing well. So firstly, welcome to my predictor paper 2. Again, congratulations on getting paper 1 done. Yeah, I've tried to get as many topics as possible that haven't come up. So that's like differentiation, implicit differentiation, vectors, binomial expansion. Parametrics did come up, but not the proper parametric. So I've got that in there as well. What else is there? Vectors, I think I've said vectors already, arithmetic sequences series, and circles, etc. Some other stuff. So yeah, that's pretty much it. The paper is 101 marks. Okay, so normally my papers are a bit longer because there's more marks, but I've got it down a bit. Overall, I think it's a very straightforward paper. There are definitely tricky questions, especially the last one and the one before that actually. But overall, I think it's a pretty okay paper. Okay, so yeah, I've got it done now. Hopefully, you're watching this not too long after I'm actually making this video. So hopefully by the weekend, I filmed some parts of these questions before paper 1 dropped. So if you see the room change or my top change or whatever, then just mind your business. Okay, I've been getting this done. I've been slaving away at this out. So yeah, that's pretty much it. Let's get into the walkthrough, man. All right, so it says, given that theta is small and in radians, use the small angle approximations to find an approximate value of 1 minus cos 6 theta over 3 theta sine 2 theta for 3 marks. So small angle approximations, I always just write them out first. They're in the formula book, but write them out. Sine theta is approximately theta. Cos theta is approximately 1 minus theta squared over 2. And tan theta is approximately theta as well. Okay, now which ones do we have? We've got cosine and sine, so I don't need the tan one, but it's always good to write out anyway. So what do I have? I've got sine of 2 theta. So remember, this argument is approximately that argument. So if I now make it a 2 theta, then I have to make that a 2 theta as well. So let's do that. So I put 2 theta here. That means it'll be approximately 2 theta. Okay, and then we've got 6 theta for the argument of cosine. So that will change and that will change. So this would be a 6 theta. And that would mean that this becomes a 6 theta as well. So you need to put in a bracket, okay? And then now we're just going to put those in. So we're going to have 1 minus, and then we're going to have the small angle approximation, which is going to be 1 minus 6 theta all squared divided by 2. And then this is going to be divided by 3 theta. I don't need to change that because it's just theta. There's no sine or cosine with it. So it's just going to be 3 theta there. And then this here approximate is going to be 2 theta. Okay, from here we just tidy up. So what we're going to do is numerator is going to be, that's a minus 1, so just expand on that bracket, is going to be 1 minus 1 and then plus that 6 theta all squared divided by 2. Now on the denominator we're going to have 3 times 2, which is a 6, and then we're going to have theta squared. Okay, and then from here the numerator 1 minus 1 is 0, and then 6 theta all squared is 36 theta squared. So I'm going to have 36 theta squared divided by 2. Let me just make that not that neat. 36 theta squared divided by 2, and then this is all over 6 theta squared. Okay, 36 divided by 2 is 18. So I have 18 theta squared over 6 theta squared, and then cancel, 18 divided by 6 is 3. So therefore the answer is just 3. And that's it. Done. Okay, so it says the sequence U1, U2, U3 is defined by UN plus 1 is equal to PUN plus Q, where P and U are constants, P and Q are constants. Given that U1 is equal to 5 pi, it says write down U2 in terms of P and Q for 1 mark. So this is just recurrence relation. So remember what I always do is this. You've got n plus 1 here. You've got n here. The one on the left is 1 more than the one on the right. So I can say that, for example, U2, which is what we're looking for, is going to equal PU1 plus Q. And then obviously we know that U1 is 5. So I've got U2 is equal to P times 5 plus Q. So therefore U2 is going to equal 5P plus Q. And that will give you the 1 mark. So that's fine. Put that down. U2 is equal to 5P plus Q. And then it says for part B, given also that U2 is 12, and the sum from R equals 1 to 3 of UR is equal to 50. Part B says find the value of P and the value of Q for 3 marks. So this one here, they're asking us for the values of P and Q, 2 letters. How do you do that in maths? You solve simultaneously. So what I need to do is form 2 equations in terms of P and Q and then solve it simultaneously. So Looking at the first bullet point, they've told us that U2 is 12. That's very helpful because that tells me if U2 is equal to 12, that tells me that 5p plus q, which is U2, is equal to 12. So that will be my first equation. And then I need a second one. I can do that from the second bullet point. So remember sigma notation. What does this actually mean? We've got UR from R equals 1 to 3 is equal to 50. This means that if I sum the first three terms, U1 plus U2 plus U3, this is going to equal 50. And I can probably use this to figure out another equation in terms of P and Q. So what do I know? U1 is 5. U2, they gave us that, is 12. So I can put that there. And then plus U3 is equal to 50. Okay. From here, what can I do? I can say that 5 plus 12 is 17. But U3 is equal to 50. And that means that U3, whatever U3 is, no, I mean it's 50 take away 17, which is 50 take away 10 is 40, take away 7, 33. U3 is 33. Now, what I want to do though is I want to form an expression in terms of P and Q for U3, and I can do that from the recurrence relation. Remember, it's UN plus 1 is equal to P UN plus Q. Let me just check that. UN plus 1 is P UN plus Q, exactly. So U3 in terms of P and Q is going to be P U2 plus Q. And we know what U2 is. U2 is 12. So I can say that U3 is equal to U2 is 12, isn't it? 12P plus Q. And then obviously that's 33. So we've got our second equation. So what I'm going to do is I'm going to say from there that 12P plus Q must equal 33. Okay, that is U3. Okay, we've got an expression for U3. 12p plus q, and we've actually got the numerical value, 33. So we've got an equation in terms of p and q, and we have that one already. 5p plus q is equal to 12. So we've got two equations in terms of p and q. This is just simple equation. So what I can do, let's take away. 12 take away 5 is a 7, so 7p. Q's will cancel. 33 take away 12 is 21, I believe. Yep. So that means that p is going to equal 21 over 7, which is 3. Now that I've got p, I can just plug it into either one of these equations to find out what q is. I'll plug it into the second one. So doing it there, I'm going to have 5 lots of p, which is 3, plus q is equal to 12. So what do I have? I've got 15 plus q is equal to 12. What do I add on to 15 to make 12? It has to be negative with minus 3, isn't it? Q is going to equal minus 3. Okay. So that is our answers. So I'll just do it here. So p equals 3 and q equals minus 3. These are the values of p and q. And that's it. That will give you the 4 marks for this question. Okay, so question 3 says, relative to a fixed origin, points A, B, and C have position vectors A, B, and C respectively. Given that A, B, and C lie on a straight line, B lies 1/4 of the way from A to C. Show that B is equal to 1/4 times C plus 3A for 3 marks. So this one, I really like this question. You guys will probably recognize it. I've adapted it from one of the past papers. Can't remember which one. But yeah, vectors. How do we go about doing this one? So I'm going to say we've got a fixed origin. Let's just call that point O, right? And then we know that A, B, and C lie on a straight line. So let's just say, for example, let's say it's like that. Okay? Let's just say this is our straight line. And let's say this is the point A. This is the point B, which lies 1/4 of the way from A to C. So the B is going to be closer to A than it is to C. So let's say it's like there. Let's say C is there. Okay? We want to show that B, which is going to be the position vector OB, right? I'm going to write this here. B is equal to OB, isn't it, right? We want to show that O to B is equal to 1/4 times C plus 3A. So what I'm going to do is I'm going to draw all of these lines like this. So I'm going to draw this there. It's that. Hold on. Like that. And then I'm going to draw O to B, which is going to be like that. And I'm going to draw O to C, which is going to be like that. Okay? So then now what do we have? O to A is just A. Like that. O to B is B. And then O to C is C. Okay, we want to figure out what O to B is. So this vector right here, right? We want to show it is, I should say, right? What is that? Well, how could you go about showing that? Well, when I look at it, we can just say from here, if I was to do this, for example, right there, then just from the diagram, we can see quite clearly that O to B, whatever that is going to be equal to O to A plus A to B. Okay. So we just need to find out what both of these are, that we're done, right? O to A quite clearly is A. Now, what is A to B equal to is the question. Well, we could figure out what A to C is, the whole line, right? Let's write this here. A to C, right? This vector here, A to C, right? We could go along, let's write this here. We could go along this one, A to O, which would be minus A. And then we can go along O to C, right? So I'm going to say A to C is going to equal A to O plus O to C, which is going to equal minus A plus C, right? So now that we've got A to C, remember, they've told us that B lies 1/4 of the way from A to C. So this right here is 1/4 of the way, right? And this has to be obviously 3/4, okay? So therefore, what we can say then is that A to B is going to equal 1/4 of the vector A to C, wouldn't it? Okay? And then obviously from there, we know what A to C is now. It's just minus A plus C. So now we can plug that into O to B, because remember, O to B is O to A plus A to B. So if I write this here again, O to A, sorry, not O to A, O to B. O to B is equal to O to A plus A to B. We know what each of these are. O to A, we already knew was A. A to B, we now know is 1/4 of minus A plus C. Okay? So where we're at, we need to show that it's equal to that. So let's do this and see what we get. So we're going to have A, expanding that bracket is going to be minus 1/4 A plus 1/4 C. Okay? And then from here, what do we have? We've got A minus 1/4 A. That's 1. 1 take away 1/4 is 3/4. So 3/4 A, and then plus 3/4, sorry, not plus 3/4, plus 1/4 C. And what form do they want it in? They said they want 1/4 C plus 3A. So we can see quite clearly, if I take out 1/4 from there, I'm going to have 3A plus C. And then from here, all I need to do is just swap these around. So C plus 3A as required. So therefore, we can say that O to B, or B, right, which is O to B, because they said B, isn't it? Yeah, B is just equal to 1/4 times C plus 3A. And that is it. I really like this question. It's quite niche. Hopefully it comes up on Thursday. Is it Thursday? Yeah, it's Thursday. But yeah, that's it. Done. Okay, so question 4 says, in an arithmetic series, the sixth term is 2. The sum of the first term terms is minus 80. For this series, find the value of the first term and the value of the common difference for part A. So they want A and D. Okay, they've given us 2 bullet points with 2 bits of information. We need to create 2 equations, solve this simultaneously. Very straightforward. So remember, generally speaking, the nth term of an arithmetic series or sequence is A plus n minus 1D. They've told us the sixth term, so n will equal 6 within it. So the sixth term will equal A plus, if n is 6, n minus 1 will be 5. So A plus 5D, this is equal to 2, right? That's from the first bullet point. The second bullet point says the sum of the first 10 terms is minus 8. So this is the Sn formula, so we need to use. So Sn, remember, is n over 2 times by 2A plus n minus 1D, okay? Now, they've said that the sum of the first 10 terms, so that's S10, that's going to be 10 over 2. And then 2A plus n, if n is 10, n take away 1 will be 9. So 9D, and then this is going to equal minus 80. And then let's just tidy this up a bit. 10 over 2 is 5. So 5, 2A plus 9D is equal to minus 80. If I divide by 5, I'm going to have 2A plus 9D is equal to minus 16. So I've got my 2 equations. This one right here, like that, and then this one right here. So we're going to solve these 2 simultaneously. So what we're going to have, so let's write them. We've got A plus 5D is equal to 2. And then we've got 2A plus 9D is equal to minus 16. So what am I going to do? Let me times the top one by 2. Times that by 2. Then I'm going to have 2A plus 10D is equal to 4. And then the bottom one is 2A plus 9D is equal to minus 16. So take away, take away, take away. That will go. 10 take away 9 is 1. So I've got D is equal to 4 minus minus 16. That's going to be a positive 20. Okay. So D is equal to 20. To get A, plug it into either one. Plug it into A plus 5D equals 2. So A plus 5D is equal to 2. But we now know that D is 20. So A plus 5 lots of 20 is equal to 2. That means that A plus 100 is equal to 2. So that means that A is going to equal 2 take away 100, which is minus 98. Okay, so therefore we can say that A is equal to minus 98 and D is equal to 20. Okay, so that's done. That's part A. Part B says, hence find the smallest value of n for which the sum of the n terms is greater than 8,000. So again, it's just algebra. Use the Sn formula, make it greater than 8,000, then solve the inequality. Okay, So let's do that. So let me just put this here. So Sn has to be greater than 8,000, and we want the smallest value of n for it that's possible. We have A and we have D, which is right here. A is minus 98, D equals 20. So A equals minus 98 and D is equal to 20. The Sn formula, we've written it. Let's write it again. Sn is equal to n over 2, 2A plus n minus 1D. Okay? So we want this to be greater than 8,000. But we've got A and D, so we can put that in. So therefore, it's going to be n over 2, and then 2 lots of A, which is minus 98, plus n minus 1. I'm going to put n minus 1 there. Put the D as 20 at the front. Just nicer to look at. And this has to be greater than 8,000. So we have to solve this inequality. If I expand that, I'll get an n squared somewhere. So it's a quadratic inequality we need to solve. Okay. So what am I going to do? Let me times by 2. So I'm going to have n and then bracket 2 minus 98 plus 20. I'll expand that after minus 1. And then it's greater than, that will be 16,000. Now, what's 2 times 98? Smaller than 200. 194? Yeah, 196, sorry. I had 4 in my head because you take 4 away by 6. Yeah. N and then minus 196 plus 20n minus 20. Like that is greater than 16,000. Like that. Okay. And then n is going to be, or let's do this, 20n. And then what's that? That's 196 plus 20. That's 206. That's 216. That's minus 216. Is greater than 16,000. Like that. And then now we're going to have 20n squared minus 216n is greater than 16,000. And then from here, we're going to have 20n squared minus 216n minus 16,000 is greater than 0. So we need to solve that. What's the biggest number we can divide by? It's not 20. What's 216 over 20? Yeah, it's not 20. Not 10 either. 4. And divide by 4. That will give us 5n squared minus what do I get? 54. And then that one would be, if I divide that by 4, that would just be 4,000, isn't it? I don't think we can go any lower than that. And then let's just use the quadratic. So what does the question say? Solutions relied entirely on calculated logic will not be acceptable. So I'm going to use the quadratic solver. Someone let me know in the comments. Can I use it from here? I think I can, because obviously I've used algebra. I've shown this here. I've not relied on entirely because I still need to interpret it. But let me know in the comments. 5 and then 3. So 5 minus 54 minus 4,000. Like that. It's 34.1. So if I was to sketch this now, so quadratic inequality, so we're sketching this graph, right? So minus 4,000 is going to be like right there. And then we've got a root at, what was it? 34 point something, 34.19, blah, blah, blah. Let's just say that's like there. 34.19, blah, blah, blah. And then what's the other root? Minus 23. So let's just say that's like there. Minus 23, blah, blah, blah. 95. Like that. So the quadratic will look like this. Something like that. We want it when it's greater than, so when it's above, so it's going to be either this, it's going to be either that. Now, obviously, because we are dealing with a series, n is the position of the sequence, so we know it can't be this one, so we can immediately disregard that. Has to be only n is greater than 34.19, blah, blah, blah. Okay, that is the only possible value. Let me just write since n is greater than 0. Okay. So with that being said, let's read the question one more time. The question asked us for the smallest value of n for which the sum of the n terms is greater than 8,000. So what we're saying here in context is that when n is greater than 34.19, the sum is greater than 8,000. But n is an integer. Okay. So if n equals 34, that's too small. Okay. So the next biggest value has to be 35. We round up to 35. n has to equal 35, right? This is the smallest value. Again, just to contextualize it, 34.19, we're saying it's just a bit more than 34. 34 would be too small then. So this one is 35. Yeah, that's it. I'm sure with the graph and everything, that should be fine in terms of me using a quadratic solver to solve that, because those numbers aren't quite nice. So yeah, that's it. Done. Okay, so it says a curve has equation y equals 3x squared minus 4x. The curve passes through the point P, which is 2, 4. Use differentiation from first principles to find the value of the gradient of the curve at P for 5 marks. So first principle, so remember the formula, f dash of x is going to equal the lim as h tends to 0 of f of x plus h minus f of x divided by h, okay? So that being said, what's our f of x? F of x is the function y. So f of x is equal to 3x squared minus 4x. So f of x plus h, remember composite functions. If this is an x here, this is our input, whatever must be here and here, this must be x2. So if this is x plus h, then an expression for f of x plus h would be 3 and then x plus h all squared minus 4 lots of x plus h. So now I'm in a position to just put everything in. So I'm going to just say then that it's going to be the lim as h tends to 0 of f of x plus h, which is this thing here, 3x plus h all squared minus 4 lots of x plus h. And then I'm taking away f of x, which is this thing here. I'm going to take away like that. 3x squared minus 4x. And it's going to be all over h, isn't it? So let's expand and simplify. So doing that, what we're going to have, I have a 3 there. X plus h all squared is x squared plus 2xh plus h squared. That's going to be minus 4x minus 4h. And then I've got minus 3x squared plus 4x. Like that. This is going to be all over h, isn't it? So let's expand this bracket. 3x squared plus 6xh plus 3h squared minus 4x minus 4h minus 3x squared plus 4x all over h. Okay, so what cancels out? So what do I have here? I've got a 3x squared. I've got a 3x squared. And I've got a minus 3x squared. Those goes. They go. What else do I have? I've got a minus 4x. And I've got a 4x here. Those cancel. Is that the only thing that cancels? I think so. Yeah. So now I'm going to say cancel, 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 cancel. That means I'm left with the lim as h tends to 0 of 6xh plus 3h squared minus 4h all over h. And then from here, what I could do is I could take out a h. I'm going to have 6x plus 3h minus 4 divided by h. Like that. And then those will cancel. And then what I can say then is that the lim, my gradient function, dy dx, is going to be the lim of 6x plus 3h minus 4. Right? So what you do when you get to this step here, h tending to 0 is essentially h equaling 0. So it's just equal to 6x plus 3 lots of 0 minus 4. So therefore it's 6x minus 4. Okay? So this is what dy dx is equal to. dy over dx is equal to 6x minus 4. Let's just check by just doing normal differentiation if that's it. 2 drop to the front, 6x minus 4. We want to find the gradient, the value of the gradient of the curve at P. That's when x is equal to 2. What I'm going to do now is just simply plug into there. So dy dx when x equals 2 is going to equal 6 lots of 2 minus 4, which is 12 take away 4, which is equal to 8. And that's it. That will give you the 5 marks. Done. Okay, so it says the distance, d meters, traveled by a robot t seconds after it starts moving is modeled by the equation d squared is equal to at plus b, where t is between 0 and 30, where a and b are constants. Given that the robot had traveled 3 meters exactly 2 seconds after it started moving, the robot had traveled 5 meters exactly 8 seconds after it started moving. Part A says find the complete equation for the model, given the values of a and b to 3 significant figures for 4 marks. So this is just plugging these values into the formula, figuring out what a and b are. So it's not too bad. So part A, this sentence says telling us travel 3 meters. Distance is d, so d equals 3 when t is equal to 2. Okay, so using d squared is equal to at plus b and plugging in those values, then it's going to be 3 squared. 3 squared is going to equal a lots of t, which is 2, plus b. So therefore, I have 9 is equal to 2a plus b. Okay, so that's my first equation. Second equation, this is d equals 5. This is t equals 8. Okay, so the second equation is going to be 5 squared is equal to a lots of 8 plus b. That tells me that 5 squared is 25. So 25 is going to equal aa plus b. Okay, so we got equation 1, we got equation 2. We can just solve these simultaneously to figure out what a and b are. So what I'm going to do, let me write this aa plus b is equal to 25. And I'm going to write 2a, sorry. 2a plus b is equal to 9. Okay, so take away. I'm going to have 8 take away 2 is 6. So 6a is equal to, the b's cancel. 25 take away 9 is 16. So therefore, a is equal to 16 over 6, which is equal to 8 over 3, which is approximately, calculator, 8 over 3, 8/3 is equal to 2.6 recurrent. So to 3 significant figures, that would be 2.67. All right, put it there. So a is equal to 2.67. That's fine. B, we can find out because we now know what a is. So plugging it into either one of these, to be honest. I'll plug it into this one. 2a, a is 8/3. I'm going to use that value. 8 over 3 plus b is equal to 9. So that's 16/3. So 16 over 3 plus b is equal to 9. So therefore, b is equal to 9 minus 16/3. So therefore, that is equal to 9 take away 16/3. So 9 take away 16/3 is equal to 11/3, right? 3.6 recurrent. 11/3, which is 3.6 recurrent, which is going to be 3.67. Okay, so therefore a is equal to 2.67, b is equal to 3.67. So therefore the model d squared is going to equal at, so 2.67t plus 3.67. So that's it. And then now that we've got the model, we can do part B. It says, given that the robot had traveled 7 meters exactly 18 seconds after it started moving, evaluate the model, given reasons for your answer. So what I like to do with these questions, right, is this statement here, the robot traveled 17 meters exactly 18 seconds after it started moving. This is a fact, right? Where's my pen? This is factual. This is true, right? Now remember, our model is meant to essentially model the movements of this robot as accurately as possible. So we'd want to, we'd hope that if I was to use values in my model, that it would give me something thereabouts, right? 7 meters after 18 seconds. So what I'd want to do in part B is we've got d squared is equal to at plus b, which obviously we've got the values of a and b. I'm going to plug in the time, which is 18 seconds, and I want to hope to get a distance of 7 meters approximately, okay? If that is the case, then it's a suitable model. It's reasonable, okay? So I'm going to have d squared is equal to 2.67, and then it was 18 seconds, wasn't it? Plus 3.67, okay? And I'm looking for the distance, which I'm hoping is something somewhere around 7 meters, okay? 18 seconds, yeah, that's fine. So let's plug it in and see what we get. So it's going to be 2.67 times 18 plus 3.67. And this is equal to 51.73, isn't it? So d squared is going to equal 51.73, which means that the distance is going to be the square root of that, 51.73, which is equal to root answer 7.192. 7.192. 7.192 to the nearest whole number. This is approximately 7 meters, right? The nearest whole number, right? So because of that, we can say that this model is suitable, right? The distance approximately is 7.192. If I write it to the nearest whole number, that is 7, right? It's close to 7. So we could say close to 7 meters. Therefore, what did they say? I like to use the language of the question. Evaluate the model. The model is suitable. Is suitable. Let me just put this in a box so I know that it's clear. So this is the conclusion here. Yeah, that is the conclusion here. So close to 7 meters, approximately 7 meters, 7 meters to the nearest whole number. So therefore, it's a reliable model. It's suitable. And yeah, that's it. That's it. Done. Nice. All right. So question 7 says the circle C1 has equation x squared plus y squared plus 8x minus 10y is equal to 29. Part A says find the coordinates of the center C1 and the exact value of the radius of C1. So this is just standard year 12 stuff. So we first have to complete the square. So let's group them. We have x squared plus 8x plus y squared minus 10y is going to equal 29. Complete the square on both terms. So I'm going to have x plus 4 all squared, take away 16, plus y minus 5 all squared, take away 25 is equal to 29. So that would be x plus 4 all squared plus y minus 5 all squared is equal to 29 plus the 16 plus the 25. So what is that equal to? 29 plus 16 plus 25 is equal to root 70. Is equal to 70. I'm getting ahead of myself. The radius will be root 70. So we have this here, plus 4, and then plus y minus 5 all squared. So therefore, the first one is they want the coordinates of the center. So the center, right, is going to be, just set that equal to 0, x equals minus 4. So that would be minus 4 there. Set that one equal to 0, that would be y equals 5. So the center is minus 4, 5. And this is before, remember, the general formula is x minus a squared plus y minus b squared is equal to r squared. So therefore, r squared is equal to 70. So r is equal to root 70. So therefore, this is I, the center. The radius, r, is equal to root 70. And that's it. That will give you the 3 marks for part A. All right, so part B says the circle C2 has equation x minus 5 all squared plus y plus 8 all squared is equal to 52. Part B says prove that the circles C1 and C2 neither touch nor intersect for 3 marks, right? And it says you must show detailed reasoning. Okay, so firstly, let's get what we know about C2, okay? The C2, we know that x minus 5 squared plus y plus 8 all squared is the equation of the curve, of the circle. The center, set each of these equal to 0, that will be a 5, that will be a minus 8. And then the radius is going to equal the square root of that number, root 52. Okay, so now we've got 2 circles and they're saying they neither touch nor intersect. We need to prove it. Now prove, touch, intersect. You may be thinking of solving it simultaneously, applying the discriminant because we've got squares, it's going to be a quadratic, and then showing it's less than 0, yada, yada, yada. Now, typically with these, they don't typically expect you to do that with 2 circles because it can get quite messy. That's one thing. And another thing as well is think about what else you could do, right? How about visualizing it? It's only 3 marks, okay? So what you want to do, the best thing to do is to actually try and see the geometry of these problems and visualize it. So let's get a sketch going. So I'm going to draw a sketch, right? Where should I do it? I don't like these lines, you know, if I'm honest. Let's do it here. So I've got an axis like this, right? Let's draw an axis. And then what do we have? Let us, you know what, let me put it in just because I have the question there actually. I'm not a fan of these lines when I'm doing this, but oh well. Let's put this here, right? Now, I'm going to do this in different colors. Let's draw C1. Let's draw it in red. So C1, the center is minus 4, 5. So let's say minus 4 is there. Let's say 5 is there, for example. The center is going to be around here. Then we're going to draw a circle like this, right? Now, how big is this circle? That's the first thing. Is it within this quadrant here? Is it in all 4? How do we know? Let's compute the radius. This is what I like to do with these questions, right? I know that horizontally, I'll do this in green. This distance right here is going to be 4 units, right? Because it's from minus 4. This one is 5 because it's from 5 going down. 5 right there, right? So if the radius is bigger than these 2, then I know it's going to be in all 4 quadrants. So the radius of C1 is root 70. So if I compute root 70 is equal to 8.3, right? 8.36. So I know that it's bigger than 5, it's bigger than 4. So I know that it's going to be in all four quadrants. So that's always a good thing to do when you're sketching these things, okay? So I'm going to just make this a bit bigger, right? Because it is, right? It's going to be in all four quadrants. So it's going to be something like that, okay? And then obviously the center will be like that. So what I'm going to do, just because it's a sketch, it doesn't actually matter. I'm going to move the center there. I'm going to set the center is like around there. So then obviously that would mean that -4 and 5 are adjusted, right? It's a sketch, doesn't really matter, okay? So I'm going to say 5 is like there, and then this is -4, like that, okay? Now, C2, okay? Let's sketch that. Well, the center for that one is 5 minus 8. So let's just say, for example, let's say 5 is like, 5 would be like there, -8 would probably be that on there, okay? Center's there. Now, what is the radius? This going across is a 5 units. Like that, this is 5 units. And this one here going down is 8 units. Okay. So what is the radius of C2? That is root 52. So let's put that in. Root 52 is equal to 7.2, right? So it's not as big as that there, but it is bigger than 5. So that means it's going to be in the 2 quadrants below, the 3rd and 4th quadrant, isn't it? So I'll do my sketch like this. So it would definitely be something like that. Now the question is, let me just adjust it here. Let me just do it like this, right? So it's in both quadrants, right? But the question is, move that center there. Again, it's a sketch, doesn't actually matter. Question is, we know that this is how it looks, but does it touch, right? How can we show, or how can we prove it? Well, the question says, we know it doesn't, to be fair, right? Because it says prove that neither touches nor intersects. But how can we prove that? Well, if you think about it, right? If it were to touch, right? Let's say I just let it touch like that, right? Then there's a nice trick that you can do, right? If I was to do this from this center to that center, right? Then what I can say is, well, what is this? What is the coordinates? This right here is a -4, 5. And then this one here is 5 minus 8, right? If they were to touch like that, then wouldn't that mean that this distance, which we can compute, right? It's just distance between 2 coordinates, right? It would actually be the same distance as if I was to compute this radius here. Let me do it in different colors now. This radius here in green, right? Which is root 70. This is root 70. And this one right here, which is root 52, right? If they were to touch, right, then that would mean, right, let me write, if they touch, then just geometrically, right, then the distance of AB, right, I'm going to call this A, I'm going to call this B, that's what I mean, the distance between these 2 coordinates, right, this would be equal to the sum of the 2 radii, isn't it? It's root 70 plus root 52. Okay, so what I'd want to do is compute the distance between these 2 coordinates and show that the sum of the radii would have to be smaller, isn't it? Because we know that they neither touch nor not intersect. So if I find the distance between A and B, right, and compare it to the sum of root 70 and root 52, then they would have to be smaller. The root 70 plus root 52 would have to be smaller than the distance between the 2 coordinates. So that's all I need to do. So let's do that here. Do that here. Or you know what? I like the diagram. I'm going to do it on the side here actually, so we can see the diagram as well. So let me just make my pen a bit thicker. So we've got the first center, which I'm going to call A, -4, 5, and distance B, which is going to be 5 minus 8. I want to compute the distance between those. So D, we know that it's just going to be the difference between the coordinates squared, isn't it? So x1 minus x2 squared plus y1 minus y2 squared or whatever. So I'm going to do 5 minus -4. So that x coordinate minus this one, that one, plus the y coordinate is now -8 minus 5. Okay, so therefore this becomes, I don't like this thing. It gives me an arrow. That's so annoying. That's going to be 9 squared plus, that's -13 squared. What is that equal to? That's 81 plus 169. That's going to end in a 0, but I can't be bothered to think. So let me just do it here, please. So root 9 squared plus -13 squared, which is same as 13 squared, but I just like to be complete. That's 5 root 10, okay? So this is 5 root 10. What is that though? Let's square that. What do I get? Answer squared. Okay, it's the square root of 250. Okay, so it's 5 root 10, which is approximately, go back there. What is that equal to? That is approximately 15.8, right? 15.81, blah, blah, blah. Okay, that is the distance between A and B. What is the distance? What is the sum, sorry, of the two radii, right? Let's just do root 70. Root 70 plus root 52. This is equal to 15.57, right? So I'm going to say root 70 plus root 52 is equal to 15 point, was it 57, wasn't it? 57, blah, blah, blah. That is less than 15.8, the distance between the two coordinates. So because of that, what does that actually mean? That means that this circle right here is going to literally be like that, isn't it? Like that, right? Because that root 52 is not actually that yellow distance, right? It's going to be a bit smaller because the circles don't touch. So let me just draw this here. So this is the radius of that one, like that. And then root 52 is actually like that because they don't touch. Okay, so that's actually what it looks like. So therefore, we've proved it, right? Beyond reasonable doubt, right? So therefore, we can say from here, let me just zoom out a bit, do it like this. We can say that root 250, right, is greater than root 70 plus root 52, right? Therefore, the circles do not touch, right? What else could you say? Circles do not touch. The sum of the radii. Whoops, sum of the radii is too small or something like that. Sum of the radii is too small for the circles to meet. And that's it. That will give you the 3 marks. All right, so part A says find the first 4 terms of the binomial expansion in ascending powers of x of 8 minus 3x to the minus a third, where the modulus of x is less than 8/3, given each coefficient as a simplified fraction for 4 marks. So this is just standard binomial expansion. So first, let me write the formula. So remember, if we've got, let me change this to a blue. So remember, if I've got 1 plus ax to the power of n, this is going to equal 1 plus n ax plus n minus 1 over 2 factorial, and then ax squared, plus n minus 1, n minus 2 over 3 factorial times by ax cubed, and so on and so forth. So these would be the first 4 terms, generally speaking, so we got to use it for this. Now, first thing first, remember, the formula has a 1 in front, right? Our expansion here has an 8, so we need to account for that. We need to take out the 8. So algebraically, I'm going to say I've got 8 minus 3x to the minus a third. I've got to take out the 8. So if I take out 8, I'd have an 8 there. That'll be a 1. Then it'll be minus 3/8, wouldn't it? X to the minus a third. And then from our index flows, we have a product to this power. So we can split it. So it becomes 8 to the minus a third multiplied by 1 minus 3 over 8. X to the minus a third. And 8 to the minus a third, that's going to be a half, isn't it? Right? You can put it in your calculator. But so yeah, it's going to be 1/2 multiplied by 1 minus 3 over 8 x to the minus a third. So we just need to figure out the expansion of that. So I'll write out here again. So 1 minus 3 over 8 x to the minus a third. We need to figure out what this is, and then obviously times it by a half. So we can't forget that. Let me write 1/2 in red on here. Okay. So now just using the formula, you just have to basically figure out what your a is, what your power is, and then you're pretty much done. So from here, what I like to do is this. You don't have to do this, but I write as 1 plus, and then I put that minus inside, like that, and then to the minus a third. So that tells me that, for example, our a in ax is minus 3 over 8, okay, and n is minus a third. So we're just going to literally use the formulas here and see what we get. So that will be, I'll put 1/2 on the outside so I don't forget. So the first one is going to be 1 plus, and then n is minus a third, so I put minus a third like that. And then x is going to be minus 3/8. And then x, like that. And then plus, and then now we've got n, which is minus a third. And then we have to do n minus 1, which is going to be minus 4/3, I believe. Let me just do it. Minus a third, take away 1. Yeah, it's minus 4/3. So that will be minus 4/3, and then over 2 factorial, and then a, so minus 3/8 x to the power of 2. Okay, and the next one's going to be n, which is minus a third, times by minus 4/3, and then taking another one away is going to be minus 7/3, isn't it? Let me just check that though. Minus 1. Yep. And then all over 3 factorial. Like that. And then it's going to be minus 3/8 x all to the power of 3. So we just need to tag this up and see what we get. So doing that, we're going to have 1/2. And then we're going to have 1. And then we've got minus a third times minus 3/8x. So we've got two negatives that make a positive. We've got 3 at the top. Oh, the 3's will cancel. Actually, that's just going to be an 1/8, to be fair. You can put your calculator just to check, so that's fine. And then this one here. So what I like to do when I'm working these out is I like to do this. It's just easier. You won't make a mistake this way. So this right here, this expression right here, if I was to work that out, minus 3/8 all squared, that is the same as, if I square the minus 3x, that would be a positive 9/64. And then it would be x squared, isn't it? That is the exact same thing. So then the coefficient of the x squared term is literally just going to be everything times together here. Like that. So all I would do here is literally put that into the calculator and see what that gives me. Okay. So I think that's always the best thing to do. So putting that in, I'm going to have minus a third. And then minus 4/3. Over 2 factorial, which is just 2. 2 times 1, which is 2. Do I have the factorial symbol? I do. I'm going to put it in there. Obviously, we know it's 2, but I just like to always do it just for the completeness of it. And then times by 9/64, right? That will immediately give me the coefficient of x squared, right? 1/32. So therefore, I'm going to have plus 1/32 x squared. And then do the exact same thing for this one. So let me highlight this in blue. So this right here, so we have times by that. And then what is this? So this one, what is minus 3/8 cubed? So I know what that would be. That would be, because it's power 3, it's going to be minus 27. And I don't know what 8 cubed is, to be honest. 8 to the power of 3 is 512. So I'm going to have 512 here, like that. And then this would be x cubed. So then the coefficient of x cubed is literally going to be all of this then. Literally all of that. So you just put that into the calculator. So doing that now, if I go up, let's edit this. So what do we want? Let me just move this to the side here. So we want 3 factorial on the bottom. So let me change this now, actually. So on the side, we want minus 27/512, like that. And then we want minus 7/3, like that. Close bracket, and then the 3 factorial is going to go there. And then that will give us 7/768. So that would be plus, that was positive, right? Just double check that. Yeah. 7/768 x cubed. Okay. So then from now, all you got to do is just expand this. Okay. So times in that half in, it's going to be 1/2 plus 1/16 plus 1/64 x squared plus 7 over that, 7 over whatever 768 times 2 is. 768 times 2 is equal to 1536. 1536 x cubed plus ... So this is going to be your final answer. Just double check, what do they want? Simplified fraction, the first 4 terms in ascending powers of x. Yeah, that will be it. And that will give you the 4 marks for part A. All right, so part B says, use the answer from part A with x equals 2/3 to find a rational approximation to the cube root of 6 for 2 marks. So I've just got what we've done in part A summarized, and this is what you should always do, right? They love these types of questions, by the way. Always the end of a binomial expansion question, the part B, etc., finding the approximation. Write down what you've done, which is actually figuring out what the expansion of 8 minus 3x to the minus a third is up until the 4th term. It's this thing here, okay? The more terms you have, the better the approximation will be. So how do you go about doing these type of questions? You just plug in the value that they've given you into both sides, okay? So what I'm going to do is plug into the left-hand side first. So if I do write LHS for the left-hand side, it's going to be 8 minus 3 and then 2/3 to the minus a third. Put extra bracket there. This is going to become, that will cancel with that, 8 minus 2 to the minus a third. And then this is 6 to the minus a third, which from my index rules is 1 over 6 to the third, which is just 1 over the cube root of 6. Okay, so that is the left-hand side, 1 over the cube root of 6. And then now we're going to do the right-hand side. We're going to plug in x equals 2/3 into that. So that would be 1/2 plus 1 over 16 to the 2/3 plus 1 over 64 to the times 2/3 to the power of 2 plus 7 over 1536 times 2/3 to the power of 3. So we're going to plug this in and see what that gives us. So just to save a couple of seconds in the exam, what you can do for something like this, let me just need to move this here so it lets me move it. What you can do is just literally store it because it's a fraction, 2 over 3. Store it and then just use answer, right? Save a couple seconds, right? Every second counts. So 1 over 16, and then I'm going to just put answer right now. So answer, now that plus 1 over 64, and then answer squared plus 7 over 1536, and then answer cubed. And that gives me that number there, which is going to be 2851 over, was it 5184? 5184, perfect. 5184. Okay, so what have we shown then, right? We've got the left-hand side, which is 1 over the cube root of 6. And what we're saying is that this is approximately equal to 2851 over 5184. Now, if the question said, instead of the cube root of 6, if it said 1 over the cube root of 6, then we would be done. This would be our answer. But sometimes they want you to do a bit of manipulation, right? Which is not hard, right? So imagine this is an equation, right? So what you're going to do is make the cube root of 6 the subject. So you're going to times up on the denominator, times by the 5184, divide by the 2851. So doing that will just be, it will just be the reciprocal of that, isn't it? It'll be 5184 over 2851, like that. And then this will be approximately the cube root of 6. So this right here is your answer. And what you can do is you can always check what the cube root of 6 actually is and compare it to your answer to see what you've got. So if I do answer to the -1, this will give me that number there, but it hasn't given it to me in that form. So I'm going to write out 5184 over 2851. It's going to equal that there. Okay. And then now, what I'm going to do is I'm going to put the cube root of 6 in. So the cube root of 6 is equal to 1.187. So can you see? They're very close, aren't they? 1.81, 1.81. Yeah? So they're very close to each other, right? Approximately, so they're both 1.8 to 1 decimal place, right? 1.82 to 2 decimal places. So they're pretty much the same. So you know this is definitely correct. So yeah, that would be your final answer. And that's how you could always do these questions. And that's it. Done. All right, so part A says, sketch the curve of equation y equals a to the x plus 4, where a is a positive constant greater than 1. On your sketch, show the coordinates of the point of the intersection of the curve of the y-axis, the equation of the asymptote of the curve for it's just exponential graph. So remember, y equals a to the x. Now, they did tell us that a is greater than 1, which means that it will be increasing. So draw y equals a to the x, then we know that it will look like this, wouldn't it? There'll be an asymptote on the x-axis. It will go through 1 like that. But I rightly said this is y equals 0, right? X-axis, okay? And then this is graph of y equals a to the x. Now, we want y equals a to the x plus 4. Let me also write here where a is greater than 1. So that. So we want y equals a to the x plus 4. This is just graph transformation. So what I'm going to do, I'm going to say, I've got f of x here. I'm going to call f of x a to the x, right? And then I want a to the x plus 4, right? Which means I want f of x plus 4. Now I look at this in isolation. What does that mean? It means that we move our graph vertically upwards by 4 units. So every single y coordinate, we're going to add 4 to it. So that being said, what would that look like for this one here? Well, that would mean I would have this point here, y-intercept was 1. It's now going to be 1 plus 4, which is a 5. And then the new asymptote is going to be at y equals 4, right? So essentially, it will be like that. Be like that, basically. What I'll do is I'll draw it on another. I'll do it on another grid. I'll do it here. So the new graph is going to look like this. We're going to have the x and y axis as normal. X, y. The new asymptote, let's just say y equals 4 is here. Say this is y equals 4. Like that. And then we're going to just do this. And it's going to be, that looks like a straight line. Like that, basically. And this intercept right here is going to be y equals 5. This is going to be the graph of y equals a to the x plus 4. That will be it. That will be your answer. We box it. Yeah. It's in the box. Perfect. Then down. And yeah, that will be it. Let me wrap this up. Get this out the way. Okay. And yeah, that will give you the 3 marks. Let me just double check. On your sketch, show the coordinates of the point of intersection with the curved y-axis. The intercepts at y equals 5. The equation of the asymptote. Simple as that. It's done. All right, so the table shows corresponding values of x and y for y equals 2 to the x minus 2x, with the values of y given to 4 decimal places as appropriate. As you can see, the table above got the values of x with the corresponding values of y. Using the trapezium rule with all the values of y given in the table, part B says obtain an estimate for the integral between 2 and 3.5 of 2 to the x minus 2x, giving your answer to 2 decimal places for 3 marks. So I've got the trapezium rule underneath here, which is given in the formula booklet. So it's just a matter of just plugging in everything. So remember, h is equal to b minus a over n. So b minus a, your upper lower limit. So 3.5 take away 2 divided by n, which is the number of strips you have. So as a quick rule, what I like to do is this. You count all of the x values, 1, 2, 3, 4, 5, 6. Take 1 away. It's going to be 5. Okay? So that is how you get your number of strips very quickly. If you're not sure on that, then you could always just draw it out. Imagine you have like a box like this, right? And then you've got 2, and then 3.5 there, and then you can just cut it yourself. 2.3, and then 2.6, 2.9, 3.2. How many strips you have? You've got 1, 2, 3, 4. 1, 2, 3, 5. You can do it that way if you're not sure, but just cut it up, cut the x values, take 1 away. It's always going to be that. So that is going to be our number of strips here. So what is that going to be? Let me get rid of this now. What is that? That's 3.5 minus 2. That's 1.5 over 5, which is times by 2. That's 3 over 10. So h is 0.3. Okay. And then now, looking at the formula, it's y0 plus yn. That's the first y value and the last y value. So this will be y0. This will be yn. And then we'd add 2 times everything in between. Okay. So that means that it's going to be equal to 1/2 times h, which is 0.3, multiplied by y0 plus yn. So y0 was 0. N is the last one, 4.3137. And then we're going to do plus 2 lots of all of them in between. So 0.3246 plus 0.8629 plus 1.6643, and then plus 7896. Close bracket. So all I'm gonna do now is just put this into the calculator, see what I got. What do they want it to? They want it to 2 decimal places, okay? So I'm gonna put this in, see what I get for that. So doing that, let me zoom out so you can see myself and the calculation too. That might be the best thing to do. Okay? There, let me zoom out a bit more. Yeah, I think that should be okay now. So let's put that in, see what we get. So 1/2 times 0.3 close bracket, and then it's gonna be I'm gonna put the 0 in just because imagine in an exam you want to just make sure you get the calculation correct. Obviously I know I don't need to, but that's what I would do if I'm in an exam. 3137 and then plus 2, and then you know what, just because sometimes I can't trust my handwriting, yeah, I'm gonna get these here. So 4.3137, that's fine, and then 2 everything in between, so 0.3246, that's fine. 6, that's fine, plus 0.8629, that's also fine, and then 1.6643 plus 2.7896, and then close bracket, that gives me that there. So this is equal to 2.33, what was that? 2.339475975. To 2 decimal places, that is going to equal 2.34. And that is it. That will give you the 3 marks. Okay, so part C says, using your answer to part B and making your method clear, estimate the integral between 2 and 3.5 of 2 to the x plus 2x. We've got the second one, 2 to the x plus 1 minus 4x for 3 marks. So how do we go about doing these types of questions? Well, it's just algebra. So let's remind ourselves of what we did in part B. We used the Trapezium rule to find an estimate of the integral between 2 and 3.5 of 2 to the x minus 2x, right? And we found that this was equal to 2.34 to 2 decimal places. So what you want to do with these types of questions, it's always like a part C with these types, is use algebra. Your job is to essentially, this is the factor. You know that the integral between 2 and 3.5 of this is that. So you want to use algebra to basically create that, right? So let's start with the first one. We've got 2 to the x plus 2x. The only problem is that plus 2x. Am I able to algebraically form this minus 2x because that's what I want? Absolutely. Plus 2x is the same as minus 2x plus 4x. So there's nothing to say I can't rewrite this problem as this. 3.5, 2 to the x, and then minus 2x plus 4x, okay? Now, why am I writing it like that? Because I've now got this expression here. And now remember, when you're doing integration, you can integrate term by term. So there's nothing to say I can't group this integral like this, like that, like that. And so therefore it becomes the integral of 2 and 3.5 of 2 to the x minus 2x dx plus the integral of 2 and 3.5 of 4x dx, okay? So that's what we've got to do here. Now this right here, we know this is 2.34. So I've just got to work out what this is here, and I'll do that here. So I'll do it here. It's going to be the integral, I'll do it here. 2, 3.5 of 4x dx. So if I integrate that, then I will add 1 to the power, divide by the new power between 2 and 3.5. Now, 4 divided by 2 is just 2. So I can just rewrite this as 2x squared, can't I? That'll be 2x squared. So therefore, evaluating that, that's going to be 2 times 3.5 all squared minus 2 times 2 all squared. Put that into the calculator. What does that give me? 2, 3.5 all squared minus 2 lots of 2 squared. And this is equal to 33 over 2, which is 16.5. Let me just make sure 2. Yeah, looks fine. 16.5. So therefore, the answer to part I is going to be equal to the integral of 2.34, not integral 2.34, integral of 2 to the x minus 2x, which you know is 2.34, plus the integral between 2 and 3.5 of 4x, which you've just figured out to be 16.5. Okay? So it's going to be 2.34 plus 16.5, which is going to be 18.84. That will be I, and that is how you go about doing these questions. Now, double line, let's do double line. same type of thing. Again, what you know to be factual is the integral of this thing right here. This is what you know to be true. So your job algebraically is to see if you can somehow form that from this here. And can I do that? Well, first things first, I've got something in the power, right? The power changes 2 to the x plus 1, and I've got that there. Well, 2 to the x plus 1, that is the same as 2 to the x times by 2, no? Right? And then the minus 4x, right? That is the same as 2x times by 2, right? So if I just write that out there, I'm going to write this out here. 2, 3.5, like that, is going to be, this is 2 to the x plus 1 minus 4x dx, right? This is equal to the same thing as, you know what I'm going to write the 2 in front. I'm going to write 2 to the x, right? So that thing there, minus 2 and then 2x, like that there. And then what I can do from here is, algebraically, we've got a common factor of 2. So we can factor out a 2, and then we're going to have 2 to the x minus 2x, right? The x. And this is the exact same thing as we've seen, because now we've got this 2, right? When you have a constant in an integral, you can pull it out. You can bring it to the front. So it becomes 2 multiplied by the integral between 2 and 3.5 of 2 to the x minus 2x dx. Okay, so can you see we've now used algebra to get that original result, right? Which we knew from the Trapezium Rule in part B. So what I can say here is that this right here is going to be 2 times by this thing right here, which is just 2.34. So I can put 2.34 right there. 2.34. So the answer is just twice 2.34, which is just equal to 4.68. That's correct, right? Sometimes I get scared. 2.34 times 2, yeah, 4.68. And that is your answer. And that is how you go about doing these questions. Comes up regularly. Doesn't come up all the time, but it can come up, and it's always good to know how to do it. And that's it. All right, so question 10 says, given that 3 log base 2 of t plus 4 minus 2 log base 2 of t minus 2 is equal to 7, part A says verify that t equals 4 is a solution of the above equation for 2 marks. So verify, that just simply means substitute, okay? So all you're going to do is plug in t equals 4 into your equation and see if you get 7. So let's do that. So we've got 3 log base 2 of t is 4, so it'll be 4 plus 4 minus 2 log base 2 over 4 take away 2, okay? What is that equal to? So this is 3 log base 2 of 8 minus 2 log base 2 of 2, okay? Now from here, we can use our log laws. We don't need to use a calculator. That's no fun. There's no fun in that. So from here, we can say that we've got 3 log base 2 of 8 is the same as 2 cubed. Like that. Put a bracket on there so it's super clear. And then minus 2 log base 2 of 2. You should know that log base a of a is always equal to 1. So that is just a 1 right there. And then from here, we've got another log law, which is log of a to the n is equal to n log a. So that power of 3 can drop to the front and join that 3. So it becomes 3 times by 3 log base 2 of 2 minus 2. And then again, we've got 3 times 3, which is equal to 9. And then we've got log base 2 of 2 again, which is 1. So we've got 9 take away 2, which is equal to 7. So therefore, you can say t equals 4 is a solution. And that's it. That's part A done. Now, part B. It says show that t cubed minus 116t squared plus 560t minus 448 is equal to 0 for 3 marks. So we've got this equation at first, which is in terms of logs, and then we've got no logs anymore. So we've got to use our log laws to get that result, okay? So what I'll do is let me just screenshot this and then screenshot the other part to show that so we know where we need to go. So that's what we need to start with here. And then obviously I'm going to get that there. So I don't think this is too bad of a question, but we'll see how it goes anyway. So this is what we need to get to. We put that there, and then this is where we are at. So what I'm going to do first is, you should always bring the logs together, but I can't at the moment with these numbers in front of them. So what I'm going to do Let me just put this here. I don't want my face to be. I'll put it in the bottom corner right here. All right. So doing that, what I'm going to do is I'm going to bring the powers up first. So I'm going to have log base 2 of t plus 4 all to the power of 3 minus log base 2 of t minus 2 all squared, isn't it? Okay, this is going to equal 7. And then now I can combine these logs. Remember, log a minus log b is log a divided by b. So I can write this as log base 2 of, and then t plus 4 all cubed divided by t minus 2 all squared. And this is going to equal 7. Okay? And then from here, remember, we're trying to get this result in the bottom corner. We need to get rid of the logs. Okay? Now, what you always do is this. It's very, very simple. What I can see right here is a log of base 2. To get rid of the logs, you've got to raise both of these with that same base, like that. And what happens is literally goodbye, goodbye. And then that means you're going to be left with t plus 4 all cubed divided by t minus 2 all squared. And this is going to equal 2 to the power of 7. And then as you can see, it's just a matter of just expanding and simplified and see what you get. What is 2 to the 7? 2 to the 5 is 32. 6,428. 2 to the power of 7. Yeah. So therefore, what we're going to have here is t plus 4 all cubed is equal to 2 to the 7, which is 128. And then we're going to times by the denominator. T minus 2 all squared. So we just expand and simplify and show that we get that. So let's do it on the next page. Let me grab this. I'll grab this, put this on the next page, and then see what we get, and then put this on the next page too. Okay. All right. So what are we gonna do? What are we gonna do? Let us let's expand this one. So if I expand this, what's the quick way to do this? I'm gonna just do t plus 4, and then I'm gonna write this as t plus 4 all squared, like that. And then this is going to equal 128 multiplied by, if I expand that, that'll be a t squared minus 40 plus 4, isn't it? And then this one, this is going to be t plus 4. And then that one will be t squared plus t 40, 80 plus 16. Okay? This is going to equal 128 t squared. And then what's that? 2, is that 512? This figure's 12. 128 times by 4 is 512. Yeah. So minus 512 t plus 512. Okay. All right. So that is the right hand side. Now the left hand side, if I do that, then I'm going to just do that. Do the t1. So it's going to be t cubed plus 8t squared plus 16t. And then plus, and then these ones I'm going to do now, 4t squared, and then 32t plus 64. This is going to equal 128 t squared minus 512t plus 512. So it's just a matter of moving everything from right to left. So let's tidy up the left hand side first. What do I have in terms of squared terms? I've got 8t squared, I've got a 4t squared, and that's it. So that's going to be plus 12t squared, like that. And then the linear terms, I've got a plus 32t, and I've got a 16t. What's that? 48? Yes, that's going to be plus 48t. And then I've got plus 64. Is equal to 128 t squared minus 512t plus 512. So then therefore we can say it's going to be t cubed plus 12t squared. I'm going to minus this one, minus 128t squared, and then plus 48t plus, because I'm going to move this one over, 512t, and then I'm going to minus 512 right now. So plus 64 minus 512 is equal to 0. So to tidy this up, what do I have? I've got t cubed, and then 12 minus 128 is minus 116. So that'll be minus 116t. 48 plus 512 is 560. And then 64 minus 512 has to be minus 448, but let me just convince myself. 64 minus 512 is minus 448. Fantastic. As required. And that's it. Done. All right, so part C says, hence, using algebra and showing you're working, solve 3 log base 2 of t plus 4 minus 2 log base 2 of t minus 2 is equal to 7, given each answer in simplest form for 4 marks, okay? And what I've got is I've actually got parts A and B, right? Because they're going to be helpful. Now, part A, it said the exact same equation I asked to solve. In part A, we verified that, or we showed that t equals 4 is a solution, okay? Which means, algebraically, for part B, the cubic, t equals 4 is a solution to that equation. So we've actually got one solution already, right? T is equal to 4. Now, the fact that they asked us to show where it is without the logs in part B, which is a cubic, is what we're going to use to solve, okay? We're going to use this instead because it says hence, okay? So I'm going to write this out again. T cubed minus 116 t squared plus 560t minus 448 is equal to 0, okay? And then when I plug in t equals 4 into that, let's just do it just for completeness, right? Plug in 4 into that. 4 cubed minus 116, 4 squared, plus 560 times by 4, minus 448. We get 0, okay? So what I'm going to do is, if I write this as a function, let's say I call it f of t, right? Then we've just shown that f of 4, right? Let's just say 4 cubed minus 116, 4 squared, plus 560 times by 4 minus 448 is equal to 0, right? What happens when you plug in a number into a polynomial and you get 0 out, right? It shows that we have a factor. Remember, this is a factor theorem, isn't it? Now, it's not explicitly stated, but you can get these type of questions whereby you start off with something else and then you just have to make that connection. But why do we need to make that connection? Because we need to solve for the values of t. If I can factorize it, which the factor theorem will allow me to do because I can use long division, that will help me out. So I'm going to say from here, I'm going to say, therefore, if I plug in 4 and I get 0 out, that means that the factor would be t minus 4, isn't it? Right? T minus 4 is a factor. Now, why is that helpful? Because now I can use long division to figure out what the quadratic factor is, and then that can help me solve it even further. So what you need to do here is obviously use long division to get what the quadratic factor is. So what I'm going to do now is I'm going to say t minus 4, right? And I'm going to use long division to figure out what that factor is. Where this goes here, isn't it? T cubed minus 116 t squared plus 560 t minus 448, okay? And then obviously long division goes as this. So we're going to do t cubed, that term there divided by the t. T cubed over t is equal to t squared. That will go at the top there. And then we times t squared by the factor. T squared times t is t cubed. T squared times minus 4 is minus 4t squared. And then we take these away. So take away, what would that give me? That will be 0. Minus 116 minus is a plus. That will be a minus 112 t squared. And then we drop this down, so it becomes 560t. Repeat the process. Minus 112 t squared divided by t is just equal to minus 112t. So that will go there. And then we say minus 112t divided by, times by, minus 112t times that is going to be minus 112t squared. And then minus 112t times that, there's going to be a positive, what's that? 448. Yes, let me just double check that though. 112 times by 4 is 448. So 448t. Take away. That's going to be nothing. What's that? 560. That's 12, isn't it? So let me just do it. 560. So I'm recording. I don't want to do this again by making silly mistakes. So yes, see, 112. Yeah, that's what I meant. 112 because yeah. Anyways, so that's fine. So we can drop that now, and this becomes 112t, and then we drop this minus 448 like that. So it'll be minus 448, and then now we just repeat the process. 112t divided by t. It's going to be 112, so that would go there like that. And then now we times, don't we? 112 is going to be times by t, 112t, and then times that by the minus 4, we're going to get minus 448. And as you can see, if I take these away, They're the exact same thing, so we're going to be left with 0. So that means that it divides perfectly, right? There's no remainder. So therefore, we can say that the cubic then is just the same as t minus 4 multiplied by t squared minus 112t plus 112, right, is equal to 0, okay? So now we need to solve. We need to solve this now, don't we? Okay. So all we're gonna do is put this into our quadratic solver, yeah, to get what the roots are. You could use the quadratic formula, but I'll just use the quadratic solver. So I'm gonna put this in here and then see what I get. So let me just write, by the way, I'm gonna solve this. T squared minus 112t plus 112 must equal 0, isn't it? Because either this is 0, which we know t equals 4, or that is 0. So we're solving that one. This gives us t is equal to, and let me know in the comments, guys, my calculator, when I put this in, it doesn't give it to me in exact form for whatever reason. So 1 minus 112 plus 112 gives me that there. So I've got these values there. Okay, perfect. So first one is 110.9999 blah blah blah, and then the next one is equal to 1.09 blah blah blah. Is it 1.09? Yeah, 009 blah 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 blah. Okay, so these are our two values, 110.7, 1.7. Now when you're solving logarithms, right, you should actually do this at the start. Okay, you always want to be very careful. So immediately what you should do is, when you look at logs, remember it has to satisfy this equation here. Now remember, with logarithms, the arguments must be positive. It can't be 0, it can't be negative. So what you can do, you should maybe do this first actually, is set both of these greater than 0, right? So for example, if I set the first one, t plus 4 is greater than 0, that tells me that t must be greater than minus 4, like that. And then if I set the second one greater than 0, that tells me that t must be greater than 2. Now, these both have to be satisfied at the same time. So t is greater than minus 4, t is greater than 2, right? We have to choose the tighter restriction, which is t is greater than 2. So any values you get, t must be greater than 2. If you get anything outside of that, it cannot work, okay? So with that being said, when we look at these two solutions, we can see that only one of them satisfies t is greater than 2, which is this one. Yeah, so we have to disregard that one, which is actually quite good that we've done it so we can see the actual numbers. So we're going to say, since t must be greater than 2, it means that t has to equal 110.99 blah blah blah. Okay, so this is the value that we're going to choose. So to answer the question, remember it says solve the equation. There's only two solutions. T equals 4, the one we found in part A, right? And t is equal to 110.99. So write this here. So therefore, only solutions, I can't spell, only solutions are t equals 4 and t is equal to 110.99. And I believe, if I'm not mistaken, I think from what I remember, it was 56 plus 12 root 21. Is that the same thing? I think it might have been that. 56 plus 12 root 21, if you use the quadratic formula. Yeah, it's that, okay? So you could use that as well. But yeah, these are the only two solutions, okay? So that's it. But yeah, my calculator, let me know in the comments, guys. My calculator doesn't give it to me in surd form, and I have no idea why. You see, this is my other calculator, CG50. But yeah, that is it. And this question finished. All right, so it says a scientist monitored the growth of bacteria on a dish over a 30-day period. The area n millimeters squared of the dish covered by bacteria t days after monitoring began is modeled by the equation log base 10 of n is equal to 0.0646 t plus 1.478, where t is between 0 and 30. Part A says show that this equation may be written in the form n equals ab to the power of t, where a and b are constants to be found. Give the value of a to the nearest integer and give the value of b to 3 significant figures. This is 4 marks. So what I'm going to do is you're going to start off with the original equation in terms of the log. So log base 10 of n is equal to 0.0646 t plus 1.478. And then if I look at the show that there's no log in it, so I need to get rid of that log. So to get rid of it, let's look at this base 10. The base is 10. So what we're going to do is we're going to raise both sides with a base of 10. So it's going to be like that. It's going to be like that. What will happen is that will cancel with that. Okay. So therefore, you're going to be left with n on the left-hand side. So it'll be n is equal to, and then it will be 10 to the power of 0.0646 t plus 1.478. And then what we're doing here is we need to get in the form of n equals ab to the t. So we're going to use some index laws now. This is the sum in the power, so I can split this, can't I? So it becomes 10 to the power of 0.0646 t multiplied by 10 to the power of 1.478. And then when I look at this, remember the form is n equals ab to the t that they want. So that tells me that a is going to be that 10 to the power of 1.478, isn't it? Because that's the only one because there's no t in there. So I'm going to swap these around. So I'm going to say it's going to equal 10 to the power of 1.478 multiplied by 10 to the power of 0.0646 t. Okay. And then now, how do I get that power of t? Well, what I can do is use another index law. Remember, a to the bc is going to equal a to the b all to the c, right? So essentially, if I have a product, I can put one power inside and put the other on the outside. So that means it becomes n is equal to 10 to the power of 1.478 multiplied by 10 to the power of, and now I want t on the outside, don't I? So I'm going to put 0.0646 in, and then I'm going to put t on the outside. And then this is quite clear to see that n equals a times b to the t. You can see this is going to be our a, this is going to be our b. So putting this in, what do we get? 10 to the power of 1.478. It's going to equal, putting this into the calculator, oops, 10 to the power of 1.478, 30.0607 is approximately, they wanted a to the nearest integer, it's going to be 30, right? So a is 30, and then for b, which is quite clearly 10 to the power of 0.0646, this is going to equal 10 to the power of 0.0646, 0.0646, it's going to equal 1.1603, 1.1603, and they wanted that to 3 significant figures, in there? Yeah, b. So that's going to be 2 decimals, which is going to be 1.16. Okay, so therefore the model is going to be n is equal to a, which is 30, times by b, which is 1.16 to the power of t. And that is your answer. That's what you'll get. So that's part A. Part B says, use the model to find the area of the dish covered by bacteria 30 days after monitoring began. Give your answer in millimeters squared to 2 significant figures. So they just want the area which was given as n, isn't it? They want n when t is equal to 30 because t is in days. Okay. So we just need to plug in 30 into that. See what we get. So B is going to be n is equal to 30 times 1.16 to the power of 30. Okay. So plugging it in, what do we get? So it's going to be 30 of 1.16 to the power of 30 gives us 2,575. 2575.496. Right, this will be millimeters squared. Now they wanted it to 2 significant figures. So 2 significant figures, that there, that will have to go up to a 6 within it. So it's going to be 2,600 millimeters squared. And that's it. That will give you the answers. All right, so it says, given that 4x cubed plus 2x squared plus 3x plus 8 divided by x squared plus 4 is identical to x plus b over cx plus d over x squared plus 4. Part A says, find the values of the constants a, b, and c and show that d equals 0, all for 4 marks. So immediately when I look at this, it looks like a partial fractions problem. So what I would attempt to do is multiply both sides by the denominator x squared plus 4, equate coefficients, etc. Right? You could do long division as well, but I'm going to equate coefficients for this one. So I've got it summarized here. So the first thing I'll do is multiply by x squared plus 4 on both sides. That will give me, on the left-hand side, it will just be the numerator. So 4x cubed You know what? Let me change the ink actually. I'm going to just change it to a little bit of a thinner ink. So it's going to be 4x cubed plus 2x squared plus 3x plus 8. And this will equal, if I times both sides by that, I'll have ax multiplied by x squared plus 4. And then I'll have b multiplied by x squared plus 4. And then I'll just have the cx plus d, wouldn't I? Okay. And then now, when equating coefficients, you just want to get the same structure. So what I'm going to do is I'm going to expand the right-hand side and get it in the form of ax cubed plus bx squared plus cx plus d. So if I expand, I'm going to have ax cubed plus 4ax plus bx squared plus 4b. And then plus cx plus d. And then from here, let's tidy up. So I have ax cubed, and then I want x squared. How many x squared terms do I have? Just one. So I have plus bx squared. And then the x terms, I've got two x terms. I've got one there. I've got an x term there, and I've got an x term right there. There's a 4a. There's a 4a, and there's a plus c. So I can factor that out, can't I? So I can say that I've got a factor of those two in green, 4a plus c, and then I've got the x there. Let me just make this capital C, like that, and then x there, and then there's only one constant term, isn't it? So I'm just going to put plus d. No, there's not. There's a 4b and there's a plus d actually. So these two. So there's a plus 4b and there's a plus d. So this must be the constant term. So I have 4b plus d. Okay. Now let's write the right hand side again. 4x cubed plus 2x squared plus 3x plus 8. Okay. We need to equate coefficients. Now we've got it in the structure that we need. So let's start with the x cubed term, which is the easiest one. So the 4 on this side is x cubed. That's the coefficient of x cubed. Coefficient of x cubed on the right side is a. So we can immediately say that 4 is equal to a, right? So we can box that off. A is 4 for sure, right? Now the x squared term. Let's do this color. The coefficient of x squared on this side is a 2. The coefficient on this side of x squared is a b. So therefore 2 is equal to b. Again, box that off. No problems whatsoever so far. So that's fine. And then continuing, let's do the linear term, the x term. So the coefficient of the x term on the left hand side is a 3. The coefficient of the x term on the right hand side is a 4a plus c. So therefore, what we can say is that we've got 3 is equal to 4a plus c. And now what can we say? Well, we've got 4a plus c. We know that a is equal to 4. So actually we can find out what c is, right? So I'm going to say that 3 is equal to 4 times by a, which is 4, plus c. 3 is equal to 4. 4s are 16, so 16 plus c. That means that c is equal to 3 minus 16, which is minus 13. So we can box that off, okay? So that's part I done, right? We found a, b, and c. Let's just write this a bit more neatly. We're going to say that a is equal to 4. We're going to say that b is equal to 2. And we're going to say that c is equal to minus 13. So that's done. And then they said that show that d is equal to 0, didn't they? For double I. So that's one mark, I'm sure. So to do that, let me just zoom out a bit. So to do that, we just continue, right? What is the constant term on the left-hand side? The constant term is an 8. It's a plus 8. The constant term on the right-hand side is 4b plus d. So that must mean that the 8 must equal the 4b plus d. So let me just write this here. This is I. Let me write, you know what I'll do? Let me write I here. So this is I, and then this is double I. We've got 8 is equal to the 4b plus d. We know that b is 2. So that tells us that 8 is equal to 4 lots of b, which is 2, plus d. That means that 8 is equal to 8 plus d. What do you add on to 8 to get 8? It's 0. Okay, d is equal to 0. Okay, so therefore we've got d is equal to 0, and then we're done. And that will give us the 4 marks for part A. Perfect. All right, so part B says, hence, using algebraic integration, find the integral between 1 and 4 of 4x cubed plus 2x squared plus 3x plus 8 over x squared plus 4. Given your answer in the form p plus q ln 2, where p and q are integers, for 5 marks. So I've just got summarized what we did in part A, right? We showed that the fraction, which is what they asked us to integrate, can be written in this form which has been reduced. It's a bit more simpler, right? And that's the whole point with these questions. You've got this type of expression here, which you can reduce, decompose it to something more simple that will allow you to integrate more easily, okay? So the first thing that I would do is, remember, these are the same thing. So I'm going to put these values in. So it's the same thing as, essentially, they're going to ask us to integrate between 1 and 4 of the right hand side, because it's the same thing. A is 4, so it'd be 4x plus b, which is going to be 2. So 4x plus 2. And then I've got plus, and then I've got minus 13x plus 0 over x squared plus 4. Okay. And then I can just tidy this up a bit, because I can say that that plus 0 I can just knock off. So it's just minus 13 on the top. And then that minus I can just actually put there. Okay. So just a nicer way of writing it. Okay. So therefore, they're actually just asking us to integrate 4x plus 2 minus 13x over x squared plus 4. Okay. Now, this is a lot easier to integrate, isn't it? Because the first two terms are just year 12 integration. So I'm going to do those first. So if I integrate that, it will be 4, and then it will be x squared over 2, right? And then plus the 2x. So that's just year 12 integration. Add 1 to the power divided by new power. 4 divided by 2 is 2. So I can write this as 2x squared, can't I? So that'll be 2x squared over there. So 2x squared plus 2x, and then minus, and then now I've got to integrate this 13x over x squared plus 4. How do I go about integrating that? Let's do that here. So firstly, I'm going to write this here. So the integral of 13x over x squared plus 4. Right? If I inspect this, well, if I look at the denominator, x squared plus 4, if I was to differentiate that, that will give me a 2x. And what we should do is recognize this type of integration. So if I put x squared plus 4 on the bottom, x squared plus 4 on the bottom, and then I put 2x at the top, then this should equal, or this will equal, I should say, the ln of x squared plus 4. Okay? This just comes from this standard result here. The integral of f dash of x over f of x is equal to the ln of f of x. Okay? So what you want to do with this one is the reverse chain rule. How do I go from this integral at the bottom here with a 2x to a 13x, right? How do I go from 2 to 13? Well, think about it. 2 times what will give you 13. Divide both sides. It's 13 over 2. Okay? So to go from the bottom one, 2x to the 13x, be times by 13 over 2. So therefore, the integral is going to be 13 over 2 multiplied by the ln of x squared plus 4. Okay? So then I can put that there. So it becomes minus, and then 13 over 2, and then the ln of x squared plus 4. And this is going to be between 1 and 4, isn't it? Those are the limits, weren't they? Yeah. So now it's just about evaluating, right? Plug in the upper limit, plug in the lower limit. What's the form? P plus Q ln 2, okay? So doing that, what are we going to have? Upper limit, plug in x equals 4. Let's do that here. That's going to be 2 lots of 4 squared plus 2 lots of 4 minus 13 over 2 ln of 4 squared plus 4. What is that going to be? 4 squared is 16. 16 times 2 is 32. So it'll be 32 plus 2 times 4 is 8. So it'll be 8. And then minus 13 over 2 ln of 4 squared is 16. Add 4, that's 20. That's going to be 20 there. And then we can just say that this is going to be 40 minus 13 over 2 ln of 20. That is the upper limit. Now the lower limit is x equals 1. Okay? So x equals 1 is going to be 2 lots of 1 squared plus 2 lots of 1 minus 13 over 2 ln of 1 squared plus 4, isn't it? So 1 squared plus 4. What is that going to be? 1 squared is 1 times 2, that's 2, plus 2 minus 13 over 2 ln of 1 squared is 1, 1 plus 4 is 5. So that'll be a 5 right there. And then we can say that this is going to be 2 plus 2 is 4. 4 minus 13 over 2 ln of 5. Okay? So now we've got the upper limit, we've got the lower limit. We just take these away to figure out what the answer is. So I'll do that here. The upper limit is 40 minus 13 over 2 ln 20 minus the lower limit, which is 4 minus 13 over 2 ln 5. Okay? So then from here, what will that give us? That will give us 40 minus 13 over 2 ln 20 minus 4. Expand that minus 4 plus 13 over 2 ln 5. Okay, so now we've got 40 take away 4, which is 36. And then we've got minus 13 over 2 ln 20 plus 13 over 2 ln 5, right? So then from here, remember, we want it in the form of p plus q ln 2. So we need an ln 2. What I can do is if I take out a 30, if I take out, sorry, from there, if I take out a 13 over 2, right? Let's just take out minus, doesn't really matter to be honest. Minus 13 over 2. Did they want plus though? Plus q and p q integers doesn't actually matter. If I take out a minus 13 over 2, then that would be ln 20. And then that would be a minus ln 5, wouldn't it? Let me just double check. Minus 13 over 2, that'll be fine. Yeah, perfect. And then from there, this is 36 minus 13 over 2. And then from our log laws, remember, we can actually divide these, right? Ln of a minus b. Ln of a minus ln b, sorry, is the ln of a divided by b. So this just becomes the ln of 20 over 5. Like that, doesn't it? 20 over 5 is 4. So therefore, we've got 36. I'll do it here. Let me just write it here. So 36 minus 13 over 2 ln of 20 over 5 is 4. So I've got that there. But they want it in the form of ln2. We want an ln2 there, which is not too bad because now from our log laws, we can say 13 over 2 and then 4 is 2 squared. So I can write this as ln of 2 squares. And then remember our log law, n log a is equal to log a to the n. So if I've got a power, I can bring it to the front. So that 2 squared I can bring to the front to join that 13 over 2. So it becomes 36 minus 13 over 2 times by 2 ln 2. The 2's cancel. So therefore we're left with 36 minus 13 ln 2. And that is it. P is going to equal 36 and Q is going to equal minus 13. Let me just double check. 36 minus 13 ln 2. P plus Q ln 2. Yeah, P is 36, Q is minus 13. And yeah, that's it. That will give you the 5 marks. All right, so question 13 says, use the substitution u is equal to the square root of x cubed plus 1 to show that the integral of 9x to the 5 over the square root of x cubed plus 1 is equal to 2 times x cubed plus 1 all to the k times by x cubed minus a plus c, where k and a are constants to be found and c is an arbitrary constant for 5 marks. So integration by substitution hasn't made an appearance yet explicitly. So how do we go about doing these types of questions? It's always just a matter of algebra, okay? You have an integral in terms of x, which you need to get in terms of u, so it's easier to integrate. So first things first, I always write the actual integral again. So 9x to the 5 over the square root of x cubed plus 1 dx. Now immediately when I look at the substitution, it's the square root of x cubed plus 1, that's the denominator. So I can immediately substitute that in, okay? So I'm going to put the denominator as u, okay? Because that is the substitution. So this is where we're at now. We're on the way. We've started with u now. Now, when I look at the numerator, I've got x to the 5. But when I look at the substitution, I've got x to the 3. And as well as that, I've got a square root. So I don't think there's much I can do with this right now. So when I'm at this position where I don't really know what to do algebraically, just differentiate. You're going to need to differentiate anyway, right? So hopefully with the differentiation, we can do something with that x to the 5. So if I write u, right, and then I'm going to write x cubed plus 1, and I'm going to change the root to a half, isn't it? Because it's a chain rule problem when I differentiate. So differentiating that, du over dx, this will equal, the half will drop to the front, and it'll be x cubed plus 1. Take 1 away from the power, minus a half. And then times by the new power, x cubed plus 1 will differentiate to 3x squared, wouldn't it? Right? So what will happen here is if I tidy this up, this will just be a half times 3 is 3 halves. So it'll be 3 halves x squared and then x cubed plus 1 to the minus half. Okay, this is what the u dx is. Now, I'm going to rewrite this back into a root just because of the substitution. It might be easier to see what to do here. So if I do that, remember that minus means it can go at the bottom, isn't it? So it's going to be 3 over 2 x cubed, x squared, sorry. And then that minus means it's going to be written as 1 over, and then x cubed plus 1 to the half, right? But remember that half is a root. So I can actually just write this as root, and then that is just a substitution, isn't it? So it's literally just this. And then obviously u is equal to x cubed plus 1, right? So I can replace this with a u. So therefore it becomes 3 over 2x squared times by 1 over u, which we can just write that all as 3x squared all on the top over 2u. And this is what du over dx is equal to. So if I want to tidy it up, I do it here. Du over dx is equal to 3x squared over 2u. Now with these problems, we're trying to look for dx, aren't we? So cross multiply, we're going to have 2u du is equal to 3x squared dx, okay? And then from here, I want dx done, so I'm going to divide by 3x squared. So 2u du over 3x squared is equal to dx, okay? And then now we can put that in our integral. So what's the integral that we're at so far? Right now, it's the integral of 9x to the 5 over u dx. But we now know what dx is in terms of du and x. So therefore, it's going to be 9x to the 5 all over u multiplied by dx, which is this thing there, 2u du over 3x squared. And then what I can do from here is just tidy up a bit, can't I? So the u's will cancel. And then I've got x to the 5 divided by x to the 2. That will be x to the 3, right? So that right there, these will simplify. That would be nothing, and that would be a 3, wouldn't it, right? And then we also got 18 over 3, which is 6. So I'll write this here. 9 times 2 on the top is 18. Divided by 3, that is 6. So 18 over 3 is 6. So therefore, this integral just becomes the integral of the 6, right? Which is, I'll highlight it so it's super clear. This is the 18 over 3. And then we've got x to the power of 3. The u's cancelled. And then we've just got du, don't we? So it's literally just 6x cubed du. Yeah? Now remember, we want it all in terms of u. So what do we do from here? If we go back to our substitution, we know that u is equal to the square root of x cubed plus 1. So what I can do is I can say, well, from here, let me just zoom in a bit, right? We know that u is equal to the square root of x cubed plus 1. So therefore, I can say that to get x cubed, because I can see that I've got it there, I can square both sides. So I have u squared is equal to x cubed plus 1. Then I can take 1 away. So I have u squared minus 1 is equal to x cubed, and then I can replace it with there. So therefore, the integral that we're dealing with now is just the integral. It's the integral of 6 times by u squared minus 1. Like that, du, okay? And then from here, this is easy. This is just 6u squared minus 6 du, okay? Now we can integrate in terms of u. Now remember, this question is in terms of x, don't we? Isn't it? So we're going to have to put it in back. So doing this, what we're going to have, what would it be? 6 is a constant, add 1 to the power, divide by the new power, and then minus 6, that would be a u. And I'll put the integral sign there, sorry, because I've integrated it. So that should be like that, and then plus our constant of integration. So now tidying this up a bit, it's going to be 6 over 3 is 2. So 2u cubed minus 6u plus c. And then from here, this is the integral in terms of u. They want it in terms of x, don't they? So let's actually get what they want. So we want this here. And this is where we are at. So we've got to do a bit more algebra, don't we? So let me just place this down. And then we can see what we can do on this page, and then we'll continue on the next page. So let's get back our substitution, or let's get rid of our substitution, I should say, right, by bringing x back. So remember, u is equal to the square root of x cubed plus 1. So therefore, this becomes 2, and then the square root of x cubed plus 1, all to the power of 3, minus 6, and then square root of x cubed plus 1, plus c, okay? So we are here. Now, what can I do? Well, when I look at this, the show that is a product. This right here is 2 times something. We've got two things subtracting. And I can see I've got a common term, x cubed plus 1 rooted. So it's going to be factorization that we're going to do, that we're going to need to do to get it in that form. So what I'm going to do, I'm going to just rewrite this as, remember that is to the half. So I write this as x cubed plus 1 all to the half. And then this is all to the power of 3. Minus 6, and then x cubed plus 1 all to the power of a half plus c. And then we can just tidy it up a bit, and then we can factorize out that expression. So let me just copy this to the next page and then put this here. So this is where we're at. And then I'll also get this as well because we're going to need this, aren't we? Just to show that we're getting it in the right form. So, okay. So this is where we're at. What do we need to do from here? So next thing I can see to do is that I've got a power of another power. So this half to this 3, we can times those together for our index laws. So we're going to have 2 and then x cubed plus 1 all to the power of a half times 3, which is 3 halves. And then minus 6x cubed plus 1 to the power of a half plus c. And then from here, as I said before, we have a product there. So we need to factorize. Now, how do you factorize these? Is this the same thing? Obviously, the powers are fractional, so it looks a bit trickier, but it's the same concept. Well, our powers here are 1/2, 1/2, and 3/2, right? You're going to take out the smaller power, aren't you? Okay? To take out the smaller power, I'm going to have, and I can also take out the 2 actually as well. I just realized we can take out the 2 from here and here. So if I take out a 2, that'll be fine. And then I can take out x cubed plus 1 all to the power of the smaller one, isn't it, right? A half. And then this is going to be my open bracket. It's going to be plus c. So then now what do we do from here? Well, remember, it's 2x cubed plus 1 all to the 3 over 2. I've got a half. So I need to times by something with the same base to get the 3 halves. What do I add on to 1/2 to get to 3 halves? You add on 2 halves, which is 1. So this is going to be a power of 1. You can check again just by expanding it out, right? That's perfect. And then this one, we're going to minus. And then what happened? We have a 2 at the front. There's a 6 that we need. We need a 3. And obviously, we took out this whole entire thing, isn't it? So it's just going to literally be like that. And then from there, what we can do is say that we've got 2x cubed plus 1 all to the half. And then that power of 1, we can just get rid of, can't we? So it's just x cubed plus 1 minus 3 plus c. So therefore, the answer is going to be 2x cubed plus 1 to the half. And then it's going to be x cubed. 1 take away 3 is 2 plus c. Okay? So now we are done. So therefore, we can say that k is going to equal that power there, which is a half. And a, the number we're subtracting from x cubed, is 2. And c is our arbitrary constant. And that's it. That will give you the 5 marks. Okay, so figure 3 shows a sketch of part of the curve C with parametric equations x equals 7t squared minus 5 and y equals t 9 minus t squared, where t is an element of the reals. Part A says find the equation of the tangent 2c at the point where t is equal to 1. Right answer in the form of x plus by plus c is equal to 0, where a, b, and c are integers for 5 marks. So this is just parametric differentiation. Okay, so I've just got it summarized here. So we'll just get started. So parametric differentiation, dy over dx is simply just equal to dy over dt divided by dx dt. Okay? So all I've got to do is differentiate y, differentiate t, put them over each other, and we're done. So what would dy dt be? Well, let's expand, to be fair. It'll be easier if we just expand. Y will equal 9t minus t cubed. So therefore dy by dt will just equal 9 minus 3t squared, wouldn't it? So that will be 9 minus 3t squared. That's fine. So that will go on the top, 9 minus 3t squared. And then dx dt, I'll do here. If x is 7t squared minus 5, dx dt is going to be, bring the 2 to the front with the 7 will be 14. And it'll be t. And then there, that will just be literally 14t. So now we can put this here. So this will be our expression for dy dx. And we want to find the equation of the tangent when t equals 1. So we need to plug t equals 1 to get the gradient of the tangent. And then we also need to plug t equals 1 into x and y to get the coordinates here. But let's find the gradient first. So if I plug in t equals 1 into there, then dy over dx will equal 9 minus 3 lots of 1 squared all over 14 times 1. This is 9 take away 1 squared is 1, 3. That's 9 take away 3 over 14. So this is equal to 6 over 14, which is the same as 3 over 7. Divide by 2, divide by 2. Perfect. So the gradient of the tangent is 3/7. So we're going to use m is 3/7. Perfect. Now we need the point. We need the actual coordinates of this point, okay? Where t equals 1. So I'm going to plug t equals 1 into x and y. So x is equal to 7t squared minus 5. So it'll be 7 times 1 squared minus 5, which is just 7 minus 5, isn't it? Which is 2. So x is 2. Y is going to equal 1. That's t is 1. 9 minus 1 squared, which is going to be 1 times by 1 squared is 1. 9 minus 1 is 8. This is just 1 times 8, which is 8. So x equals 2, y equals 8. So we've got everything we need now. We've got the coordinate 2, 8. We've got the gradient m 3 over 7. We want the equation of the tangent. So we're going to use y minus y1 is equal to mx minus x1. So plugging in everything in, we're going to have y minus 8 is equal to 3 over 7 and then x minus 2. Okay. Now they want it in the form of ax plus by plus c. So where a, b is the tangent. So we need to get rid of that fraction there. So if I times everything by 7 now to get rid of that division of 7, then I'm going to have 7y minus 56 is equal to 3x minus 2. That means that 7y minus 56 is equal to 3x minus 6. And then let's move everything from left to right. That will mean that 0 is going to equal 3x minus 7y minus 6 plus 56. That is plus 50. So therefore, 3x minus 7y plus 50 is equal to 0. And that is it. 3x minus 7y plus 50 is equal to 0. And that will give you the 5 marks. Okay, so part B says the curve C cuts the x-axis at the points A and B, as shown in figure 3. Part B says find the x-coordinate of the point A and find the x-coordinate of the point B for 3 marks. So when I look at the graph, A and B are on the x-axis, so y is 0. So that's immediately what I'm going to put in there. And also for context as well, the point A, the x-coordinate, whatever that is going to be negative. So I should put a minus there. And the x-coordinate of B is going to be positive, right? So it's just always important to have the context of the signs of the values that you're looking for, just so you know you're doing the right thing. So because y is equal to 0, it means that I can set my equation for y, which is defined parametrically, equal to 0, okay? And then I need to figure out the corresponding values of t, which will allow for the points A and B, okay? So I'm going to set equal to 0. I'll do it here. So I'm going to say that t, so I don't like the way I've written t, 9 minus t squared is equal to 0. That means either t is equal to 0 or that factor 9 minus t squared is equal to 0. So I've got one value of t, that's fine. And then that means that 9 is going to equal t squared. So therefore t is going to equal plus or minus 3 when I square root it. So we just need to plug in our values. So immediately t equals 0. If I plug t equals 0 into x, because I want the x coordinate, right? Because what we're saying here essentially is that these values of t are the ones where y is equal to 0. So they have to correspond to the x values, which is the one we're looking for. Okay, so we're going to plug in these values. So if I plug in if I plug in t equals 0 into x equals 7t squared minus 5, then I will get t equals 0. And then I have x is equal to 7 times 0 squared minus 5. That is just means that x is equal to minus 5. So it must be that one. X has to equal minus 5 there. And this is when t is equal to 0. Okay. And then we've got plus or minus 3. So say I'll use 3. I'll do it here. If I plug t equals 3 in, then I'm going to have x is equal to 7 times by 3 squared minus 5, which is going to be 7 times by 9 minus 5, which is 63 minus 5, which is 58. So therefore, x is equal to positive 58 here. And technically speaking, if I was to plug in the negative value, minus 3, we'd get the exact same thing, isn't it? Because that would just be 7 times 9 again, right? Which is 58. So the positive and negative values of t give the exact same values for x. And that is the same throughout every single x value as well, which is going to be important when we do part C. But yeah, that is it. The x coordinate of point A is x is equal to minus 5. And the x coordinate of part B is point B is x equals 58. And that's it. That will give you the 3 marks. All right, so it says the region R, shown shaded in figure 3, is enclosed by the loop of the curve C. Part C says use integration to find the area of R for 5 marks. So what do we have? We've got integration in a parametric question. So immediately you should be thinking of parametric integration. So write the formula out first. So it's going to be y dx dt. And then obviously now we have y. So y is going to be t 9 minus t squared. And then dx dt is going to be 14t, isn't it? Yeah, like that. Okay, now this, in terms of integration itself, we'll just expand this in a bit and then integrate with the power rule. This is easy integration. Question is, what are the limits, right? Let's look at that. Now, remember what we did in part B, when we were figuring out the coordinates, the x coordinates of A and B, we noticed that when we plugged in, I've got on top here actually, when we plugged in t equals 3 and minus 3 into x, we got the exact same value, right? X equals 58, right? This just goes to show, I mean, it's quite obvious, but this graph is symmetrical about the x-axis, right? Now, it's pretty clear, but obviously you just want to be sure and rigorous when you're doing these types of questions in an exam. So for example, let's just say I've got x, right? Let's define x as a function of t, like that. Then I'm going to say x of t is 7t squared minus 5. And then let's say I do x of minus t, right? The other side of the values you can use, right? It will be 7 and then bracket minus t squared minus 5. But remember, minus t all squared is just positive t squared. So that'll be 7t squared minus 5, which is the exact same as the top. So we've just proved that the values of t, whether it's negative or positive, give the exact same outcome for x. The only thing that will differ is for y, right? So for example, let's just say we chose x equals, not x, sorry, let's say we chose x equal, I keep saying x. Let's say we chose t equals 2, for example, right? What would we get when we plugged in t equals 2 into x? We get the same value out. So let's just do it. 7 times 2 squared minus 5 will give us 23, okay? So when t equals 2, let's just say t equals 2 there. Let's say x equals 23 is here, right? This is 23 right here. What value of y is that, okay? And just to be sure on the safe side, let me plug in minus 2 and show that we get that as well, 23. So t equals plus or minus 2, we get 23. What value of y does that give us? Okay, well, let's do it. 2 bracket 9 minus 2 squared. This gives us a positive 10, okay? So this one right here is y equals 10. And then this one, if I plug in minus 2 instead, so change that to a minus 2, like that, and then change this one to a minus 2 as well. Like that, this gives us minus 10, okay? So as you can see, the same value of x gives two different values of y, the positive and the negative, okay? Which confirms what we were saying about the symmetry of this graph. Now, why have I said this? Because it will help us integrate in terms of finding the areas and the limits. So essentially, what is happening is when I plug in positive values of t, it will give me the top half of this graph here, essentially. So I'll highlight this in yellow, right? This part in yellow, this upper loop, right? These are the values of t between 0 and 3, okay? Now this loop at the bottom, right? The green part, these are values of t which are between minus 3 and 0, okay? So in terms of the actual question and finding this area, to find the area, what limits are we going to use? We can just integrate between minus 3 and 3, right? Or because of the symmetry, we can actually just integrate between 1/2, between 0 and 3, and then double it, okay? So essentially, the answer to the question is either going to be equal to the integral, I'll just write y, between, I'll write dx dt, dt. You can either integrate between minus 3 and 3, or you could integrate between 0 and 3 and then double it, right? Or even minus 3 and 0 as well, same thing. So what I'm going to do is I'm going to integrate between 0 and 3 and double it, okay? So let's just, now that we've got that out of the way, we know what the limits are, we know the symmetry, let's get the integral and let's actually finish this off. So I'm going to integrate between 0 and 3 and then double it. So what I'm going to do, I'm going to copy that, put the limits of 0 and 3 and then double it. So let us, whoops, let me just make sure, let me just put this here. And then I'm going to just tidy this up. Let me put the limits first before I forget them. So I'm going to plug in, I'm going to do 0 and 3. And then double it. So I'm going to just do 2 times. I'll put 2 at the front. 2, okay? So tidying that up, it's going to be 0 and 3 of, that will be t times 14t. That's 14t squared. And then I'm going to have 9 minus t squared dt. So the answer is going to be 2 times the integral between 0 and 3 of expanding that bracket. 14 times 9 is 140, take away 14, 126. 126 t squared minus 14t to the power of 4. And then from here, this is just, 12 integration now, isn't it? Let me just double check. 14t to the 4. Yeah, that's fine. So now, doing that, it's going to be 2, and then it's going to be, integrating that, be 126 t to the 3 over 3 minus 14 t to the 5 over 5 between 0 and 3. Now, 126 over 3, I don't think that goes, to be fair. 126 over 3. It does, my bad. 42. So therefore, it's going to be 2 bracket 42 and then t cubed minus 14 over 5 definitely doesn't, but what, yeah, just leave it at 14 over 5 t to the 5 between 0 and 3. So all I've got to do now is evaluate, put the upper limit in, put the lower limit in, and we're done. So it's going to be 2, big bracket, and then it's going to be 42 times by 3 cubed minus 14 over 5, and then 3 to the 5. Okay, and then that is the upper limit, and then the lower limit is literally going to be zeros, no? Because I plug in 0 into both of those, I just get 0. So it'd be 0 minus 0, essentially, right? So there'd just be literally nothing there. So the answer is going to be equal to 2 times by 42, 3 cubed, which is 27, minus 14 over 5, 3 to the 5. So I'll just put this into the calculator and see what we get. So putting that in is going to be, let me just zoom out so you can make sure you guys can see everything. So putting that in is going to be 2 bracket 42 times by 3 cubed minus 14 over 5, 14 over 5, and then 3 to the 5, isn't it? Like that, and then close bracket like that. Let me just double check that looks all good to me. I get that there, which is 907.2, right? So 907.2, or what was the fraction? 4536 over 5. 4536 over 5. And that's it. That will give you the 5 marks for this one. All right, so question 15 says x squared plus 2xy minus y squared is equal to 12. Part A says show that dy dx is equal to minus x plus y over x minus y for 4 marks. So this is just standard implicit differentiation, standard part A. So let's start. So I've got x squared plus 2xy minus y squared is equal to 12. And then obviously we've got to differentiate with respect to x on each term. So this one is easy. This is just 2x. Now the next one requires the product rule, doesn't it? So let's do that. So let me put this, I'm going to say 2xy here. I'm going to set u equal to 2x. I'm going to set y equal to, I'm going to set v equal to y, sorry. So v equal to y. And then we differentiate both. So u dash is going to equal 2. V dash is going to equal, remember, differentiate with respect to x. This is just becomes dy dx. And then the product rule states that u v dash plus v u dash is dy dx. So we're going to just crisscross this. So this times that plus this and that. Okay. So that would mean if I was to put that there, then it would be the 2x times the dy dx. So it would be 2x dy dx. And then plus the next term, which is going to be vu dash, which is going to be y times 2, which is going to be 2y. So that one's done. And then minus y squared differentiates. Remember, differentiate with respect to x. So it's going to be minus 2y dy dx. And then the 12 will just differentiate to 0. So then remember, we're trying to show that dy dx is equal to minus x plus y over x minus y. Let me screenshot that and just get that down there so we know what we're trying to get to at least anyway. So I'll just put this here. So this is what we're trying to get to. So we don't need to keep going up and down. All right, so now it's just changing the subject, isn't it? Making dy the subject of the formula. So I'm going to keep these two on the left-hand side. So keep that on the left-hand side, and I'm going to move these two to the right, aren't I? So that will go to the right, and so will that. So therefore, it will be 2x dy dx minus 2y dy dx is equal to, if I move those over to the right, it'll be a minus 2x and a minus 2y. And then now we know what to do for it. We take out the dy dx, factorize it out. And then we're going to have in a bracket, we're going to have a 2x minus 2y. And then this is going to equal minus 2x minus 2y. I need to get these, my algebra on top of the line because it kind of doesn't look good. Anyways, dy dx then will equal, we will just divide that, would it be? So it would be literally minus 2x minus 2y on the top, and then we will divide by 2x minus 2y. So that's dy dx. Is it the same as that? It is, because what I can do on the numerator is I can take out a minus 2. So I have x plus y. And on the denominator, I can take out a 2. So it becomes 2 and then x minus y. And then I can say goodbye, goodbye. And then that leaves me with minus x plus y over x minus y. And then that minus, which is on the top, we can put it on the front. So therefore we have minus and then x plus y over x minus y as required. And that's it. That will give you the 4 marks. All right, so part B says, hence show that d squared y over dx squared is equal to 24 over x minus y cubed for 6 marks. So I've just got what they've given to us in part A, the equation of the curve and the derivative. Obviously, if we want the second derivative, we just differentiate the first, right? So that's what we're going to start by doing, okay? So we've got dy dx, and dy dx happens to be a fraction. So we need to use the quotient rule, right? So that minus, I'm going to just leave on the outside, and I'm just going to focus on the fraction. I'm going to just say that u will equal x plus y, and v is going to equal the denominator x minus y. And then if I differentiate both of these, remember it's with respect to x, we're going to have to use implicit. So this is going to be a 1 plus, and then y differentiates to dy dx, okay? And then v dash is going to differentiate to 1 minus dy dx, wouldn't it? Right? And then now the quotient rule says if y is equal to u over v, then dy over dx is equal to v u dash minus u v dash over v squared, right? So therefore, we can compute our second derivative, okay? So I'm going to have d squared y over dx squared is going to equal, remember what I said, there was a minus here. Let me put that minus in red so I don't forget. There's a minus on the outside, which I didn't use in my quotient rule, and then I've got the actual fraction. So let's put everything in, okay? So it's going to be vu dash, so these two. So I'm going to have x minus y multiplied by 1 plus dy dx. And then minus u, so these two now, right? So x plus y, and then 1 minus dy dx. And this is going to be all over v squared, and v is x minus y. So I'm going to have x minus y all squared, okay? This is d squared y dx. Obviously, the show that has 24 over x minus y, right? Now, there's no dy dx's in the show, that's what I mean to say. So that tells me I need to get rid of that, okay? So what I'm going to do is, remember, we know what dy dx is. Dy dx is minus x plus y over x minus y. So I can actually compute 1 plus dy dx and 1 minus dy dx. I can compute them a bit more. So I'm going to just say that 1 plus dy dx, right, is actually just the same as 1, and then plus dy dx, I put a minus, and then dy, so not dy, x plus y over x minus y. And obviously a plus and a minus make a minus. So this is actually just, let me write this a bit neater. It's literally just 1 minus x plus y over x minus y, okay? And then from here, I can actually, or you know what, before I simplify, let's do the other one as well. 1 minus dy dx, right, is going to equal, there's 2 minuses, isn't it, right? If I put a minus in front of there, it'll be 1 minus and then minus that x plus y. So it will just flip to a plus within it. So therefore, it's going to literally just be 1 plus and then x plus y over x minus y, which is great because now if I was to put those in there, so remember what I'm saying is that this right here is this thing, right? So we can replace that there, can't we? Okay. And then obviously this thing, put it in yellow, this thing here, and this thing can be replaced there. Okay. So what I'm going to do is I'm going to simplify this a bit more, actually, make it one fraction. So that's a 1. I can write the 1 as x minus y over x minus y. And then minus x plus y over x minus y. And then this will equal, combining the fractions because they've got the same denominator now, it's going to be x minus y minus, got to protect that x plus y, over x minus y. And then that will become x minus y minus x minus y, wasn't it? All over x minus y. And what is that? That is going to equal the x and x will cancel, won't they? And I'll have 2 minus y's. So therefore, it's going to be minus 2y over x minus y. That is 1 plus dy dx. Okay? So let's put that in the color that we have said. So this is actually that. So I'm going to put that in a moment. And then the bottom one, we just do the exact same thing, don't we? So combining the denominators, that's going to be x minus y over x minus y plus x plus y over x minus y. And then that just becomes x minus y, x plus y over x minus y. And then that there, what cancels? The y's cancel, don't they? This time. So we have 2x over x minus y. Now box that. So box that. And this is the thing in yellow. So now we've got these expressions in terms of x and y. Now the dy dx's are gone. So I can put those in. So therefore it becomes d squared y over dx squared. That minus, remember, I've still got put in red. Hold on. Let me put in equals first. Put in equals first. So put a minus there, and then let me put the equals like right here. Equals, and then big fraction, and I'm gonna have x minus y times by the thing in blue, which is minus 2y. Put minus 2y over x minus y, close bracket, minus x plus y, and then open bracket, the yellow thing, which is 2x over x minus y. And this is going to be all over x minus y all squared, okay? So let's just have a look at the show that I might bring it down actually. I'll bring it down just so we have it. We need 24 over x minus y cubed. So that tells me I need to get an extra x minus y, and that will definitely come from the numerator, as we can see, okay? All right, so let's just do this. All right, so what I'm going to do is I'm now going to times these. Remember, this is a fraction right here, by the way. So when I expand that, I'm going to just work with the numerator only. I'm going to just write numerator because it'll be faster to do the work. I'm going to just work with the numerator. I'm going to forget about the denominator for now. Okay. So if I do this and that, those two, then this will cancel. That x minus y is timesing. This is dividing. Those will cancel. So that will cancel with that. And then I'll be left with minus 2y like that. And then this one would be minus, and then I've got a, what can I do with that? I can say that that just becomes minus, and then I can put the x plus y with the 2x. So it just becomes minus 2x, and then x plus y all over x minus y. I hate when it does that thing. Let me just get rid of that quick, that arrow there. Okay, so this is where we're at now, okay? And then what can I do from here? Well, what I can do actually is, remember the numerator is what I'm dealing with. That minus on the outside, I can actually put inside actually. So I'm going to put that minus in red, right? So all I'm working with now is just the minus and the numerator. It was timesing it, isn't it, right? If I put that minus inside now, then these will flip to a positive, which is actually going to be helpful. So it's going to become minus times minus will be a plus 2y. And then that minus will times with that minus, and it'll just become plus, and then it'll become 2x, x plus y, all divided by x minus y. Okay? And then from here, what I can do is I can get an x minus y on this one by just getting a common denominator. So I'll do that. I'll do that on the next page, actually. So let me grab this, and then I'll have to bring the denominator soon as well. So all we're doing now is just working with that numerator and tidying it up. So doing that. Okay, so this is where we're at. This is just the numerator. So what I can do from here is say if I put this over 1, this needs to go higher a bit. If I put this over 1 like that, hold on, let me do it like this. Let me move this here. This fraction needs to go there. This plus, that plus, I can't grab it. Let me just write this out. this plus would be like that, okay? So we're adding these two. So therefore, this would just become 2y and then x minus y over x minus y plus, and then 2x, x plus y over x minus y. Now this is great. Remember, this is just the numerator only that we're dealing with. The denominator is still x minus y all squared, right? So we've got that. So this is really, really good. So what I can do now is combine these two, and it's going to become 2y x minus y plus 2x x plus y all over x minus y. Okay, and then from here, what can I do? I can expand this. So this becomes 2xy minus 2y squared, and then plus 2x squared plus 2xy. Right? We just check 2x squared plus 2xy. Yeah, perfect. Like that. So where we're at is now x minus y on the bottom. And then now what we can say is that the numerator for this here, I'm going to have a positive 2x squared. And then I'm going to have a 2x plus 2xy. 2xy plus 2xy is a 4xy. I'm going to have 4xy here. And then I'm going to have a minus 2y squared. And then this is going to be all over x minus y. Like that. Now, this is just the numerator, by the way. Now, remember with these type of questions, it's all about algebra. So I've got 2x squared plus 4xy minus 2y squared. If I look at the original curve, I've got x squared plus 2xy minus y squared is equal to 12, don't I? So let's just grab that and put this here, because this is going to help us immensely, right? So if I put that there, this is a fact, by the way, right? This is the equation of the curve. What we have right here is exactly double, no? So therefore, I can actually say that if I just times this by 2, then I'm going to have 2x squared plus 4xy minus 4y squared, right? Sorry, not minus 4y squared, minus 2y squared. Sorry. Minus 2y squared is equal to times by 2, 24. Okay? So therefore, this result right here is actually just 24, which is actually quite nice. Okay? So that means I can actually just say that this is actually just 24 over x minus y, which is pretty nice. Now remember, algebraically, we have just been dealing with the numerator. Remember, the denominator is x minus y all squared. So we've worked out this whole thing right here. This whole thing right here is literally just 24 over x minus y, okay? So what I can do now is bring it back, okay? So therefore, I can say this. I've got d squared y over dx squared. On the numerator, right, it is 24 over x minus y, right? We've used algebra to show that all of this working out here is just 24 over x minus y. The denominator, remember, is x minus y squared, right? So therefore, I've got x minus y all squared. And then now, remember what we're trying to show. We're trying to show that the second derivative is 24 over x minus y all cubed. So we're pretty much done. Okay. So now, just to be really sure to the examiner that you know what you're doing, let's write this as the numerator. This is the denominator right here. This is 24 over x minus y multiplied by 1 over x minus y all squared, right? We can do that algebraically, can't we? Okay. So therefore, we can say that this is just 24 over x minus y all cubed as required. Hold on, let me write this again. These arrows are annoying me. 24 over x minus y all cubed as required. And that is it. Let me know what you think of this question. I actually adapted it from a mock set question. I can't remember where, but there's something similar, but I just made it a bit harder. But I did it in one take. But yeah, let me know in the comments what you think, especially about the marking as well. I was going to give it 7 marks or 8, but I think 6 would be all right. But yeah, that's it. That's the question and that's the paper done. All right, guys. So that's the paper. I'm hoping that you guys have found it helpful with your revision. I tried to include as many topics that haven't come up in paper 1, that hadn't come up in paper 1. So hopefully this will be enough coverage to get you through next week. Yeah, good luck. Again, you guys are going to smash it. I know you guys are going to come at the paper saying way better than paper 1. I got 100%, you know? So that's what you guys are on. You guys are gonna just do amazing. But yeah, that's it. Wish you the best of luck. Again, it's always appreciated if you like, comment, subscribe, share with your friends, share with anyone you think will find these videos helpful. But yeah, we'll leave it there, and I'll see you guys for paper 3. Take care. Bye-bye.